Hello! How you guys doing? Vital, TS, I'm TS Just. How you doing? Welcome, welcome. So, I've been working a little bit on the kerning stuff off stream a little bit, just so I can, like, you know, figure out why I can't get it right. So, I've changed a few things, as you can see. Now it's actually, like, drawing to the screen, for instance. And I'm not using letters here, if you couldn't tell. So I swapped out some of the numerals, the numbers, to be, well, their value wide, essentially. So the 1 is now a pixel, 2 is a box of 2 pixels by 2, and then 3 is 3 by 3, 4 by 4, etc., etc. You get the idea. I figured it's easier to diagnose and figure out specifically what's going on in a more controlled fashion. So yeah, that's what we're going to try to be doing today, is figuring out why I can't add correctly. It's basically what it boils down to, is why can't I add? But yeah, so I think I understand the reasoning behind what I need to do and why it doesn't really work. But for whatever reason, like I said, I don't know how to, like, add and subtract properly. So we're gonna be figuring that out on stream today. But yeah, how was your guys' days? It started raining today, actually. It was raining when I went to work today, so that wasn't fun. But when I came out of work, it was like 90, well, not 90 degrees, probably like 85 degrees outside. But I mean, it's at least getting, you know, cleaned up, or heated up a bit. Now, so bro, how you doing? I need rain here. You can have some of mine. Alright, and another thing I started doing, I think this is mostly today, though, was, unrolling some loops that involve writing the buffer to the PPU. So this one right here is a 100% unrolled. So this is all with, done with a macro. Up here somewhere. Where is it? There it is. So this just writes the first 00 to 2006 twice. So it gives the very, very first address. Which is the first pattern table, right? So that's the very top here, and it writes a single row of tiles, so 16 tiles, and it just hard codes essentially a set of 16 or a set of 8 load immediates, and then some more. Load immediate in a store, and then a load a once, and then store that 8 times for the second. What's it? For the second half of the tile, because it's zeros or whatever. This works very well, actually. I think it's it only takes like 12 scan lines to go through 16 tiles. Which is nice. That's awfully efficient. 14 tiles, 14 scan lines. I can get it down to 12 if I use immediate addressing. So if I use this one instead, which would require me to have this subroutine in RAM, so I could modify the immediate values. I don't think I'm gonna go that bonkers tonight. I might later on, like off stream for kicks, just to see like how many tiles I can write per VBlank period, but yeah. Anyway, the one I am using though is partially unrolled, right? So it loops once per tile. So it loads up 8 bytes and writes them. Writes 8 zeros to get the second plane. Sunny Deer, how you doing? Bridgewater, how you doing? It would be internal, because I did the math, and I've got, like, if I use the immediate mode, I've got, like, 26 bytes left over that are outside of, what's it? zero page and outside of sprite OAM and all that. Self-modifying. I'm thinking about it. Cinedeer. I'm thinking about it. 5 ice cream bites to the PPU. 5 ice cream bites to the PPU bite. Something like that. It's like just over a K. A little over a kilobyte of data. If it's just straight LDA value store 2007. For 8 times, and then load A 0, and then store A 2007 for 8. And that one right there, store 8 times. Tasty Dude, how you doing? It's going alright. I can't complain too much tonight. I think I finally figured out what I need to do. Logically, anyway. I'm still working on the math, so I'm gonna embarrass myself tonight with that. I'm not gonna be using that tonight, though. I'm not gonna be using the 100% unrolled in RAM thing tonight. So I don't need to go that bonkers with it. Instead, I'm going to be using a, like I mentioned before, a partially unrolled loop. So it loops once per tile. So it loads up and then stores 8 bytes, which is the first plane, the first half of the tile, the first 2 colors essentially. And then, well, I mean, kind of sort of the first the first half of the tile, and then it just writes out the second half that's all zeros. But that happens 16 times, and I think this is what was it, like 20 scan lines? So very much doable in you know, real world applications, I guess. True developers use unrolled speed code. Yeah. I still have them both in the ROM right now, so it's not like I'm excluding one. So this is what the unrolled one looks like. Well, unrolled. Bunch of stores, load A, store A, load A, store A, load A, store A. You know, the other one looks like this. But yeah, so as for the I'll get that there. As for the actual assembling of the name of, well, the text, like I mentioned earlier, I swapped out to using squares, so I can easily see the width of the character. So if something's 4 pixels wide, it's also 4 pixels high, for instance. And I'm going to be using the 4x4, or no, this one here. Yeah, the 4x4 to test, to see if I can figure things out. Hayes, how you doing? Welcome, welcome. How was stream, Hayes? What are you playing tonight? AK Maffin, how you doing? True developers design their own accelerator hardware, right? Speaking of hardware, Bridgewater, did you ever get that keyboard working? That you were working on the other day? But yeah, so I'm using the 4 pixel square, which incidentally is 5 pixels wide because there's a single pixel of buffer in between there. Still making the kernel. I am still making the kernel. Which means that when it's all assembled, it should look something like this. There'll be more of them on there. However, currently, you'll notice it don't look like that. It doesn't look like that at all. It's a little broken. It's a little bit broken. Like the first tile's fine, right? The first tile. Oh, where is it? The first tile looks fine. It's 1, 2, 3, 1, 2, 3. Beautiful. Second tile, well, it gets the first half right. It gets part of the second half right, and then it just there's supposed to be a line right there. 1 and 1 is 1. Yeah, well, did I watch Mole Man 4? I have not. No. How you doing, Cody? By the way, welcome. What I haven't managed to do yet is figure out what happened to the screws. Oh no, you lose screws? Turns out I forgot to put the harness back into the power supply board. That'll do it. That'll do it. Don't tell me you don't like the standard character generating software, so you made your own character generator and you didn't like your own IDs for developing the character. I mean, almost, Hayes. So I didn't admittedly look for something to do this for me. I mean, I know of audio engines out there, right? I chose actively not to use an audio engine. For this, I'm not sure if there's anything out there that I can just drop in to do it for me. Yeah. But at any rate, I almost have it going. I should have it working tonight. Justin, how you doing? Who needs fonts when you plot the dots yourself? I mean, technically, I am doing that. And yes, I am using Vim. 1983. What was it around? I don't even. Actually, no. Vim itself was in the 90s. V was earlier. Vim was based off of V. Worse than losing screws. I have 6 of one kind of screw that I should only have 4 of, and none of the other that I should have 2 of. They have a different thread. Oh, that's unfortunate. That is unfortunate, Bridgewater. Oh. So, yeah, so I am still using the shifting for this, and then ORing things together. But clearly my math isn't quite right. Trying to learn assembly. What is the difference between sub-I and sub-S in assembly? What language? Because the assembly that I work in does not have either one of those instructions. Macros. ARM. Yeah, I'm not. I have no idea. I'm sorry. I don't know ARM assembly. Someone in chat might be able to help you out, though. I don't know. I was playing Tiger Claw and Willow Pattern. Completed Tiger Claw. It was a 2014 game made for a 16K competition. And made into a cartridge. Oh, nice. Not bad. Sub-I is for immediate data. S is for something. Well, setting result file, maybe? Possibly. I'm realizing easy. The finger bonus gets it. I mean, you're gonna need some glue with that one, though. Don't you ancient taste to do or something? Right. So anyway, the first thing I wanted to do, though, was write down certain values that I expect in this process. Let's save this flag. Okay, there you go. So there's 3 values essentially that I need to keep track of that I am apparently not doing correctly. The first one is the initial offset of a given character. That's where the character starts, right? So for the first character, it's going to be 0 because it starts at the first column right here. For the second character, it's going to be 6 or 0, 1, 2, 3, 4, 5. So it's going to be 5 for the second character. For the third character, it's going to be 1, 2, 3. No, 2. 0, 1, 2. Because it's 0 based. Which I think is correct, because we're getting the right start on the second character there, right? And then for the fourth character, that should be 0, 1, 2, 3, 4, 5, 6, 7. That should be 7, right? So an offset is 7. So it starts in the 7th column. For some reason that ain't happening. And it might even just be like deadlocking there, because I think there's supposed to be more than just 4. How many are there supposed to be? Oops. SP. Text. Oh, yeah. Okay, this is 8. Okay, so it's breaking pretty significantly then. Alright. So many subs on to be assist, no risk. ARM is pretty neat. Prediction, predication on almost every instruction. The option for computer jumps, stuff like that. Nice. Armor assembly is great, but leg assembly is better. Nice. Nice. You stealing that one, Hayes? Oh, you did properly credit AK Maffin on that one. Yeah, so that's the first what's it? Value that I need to keep track of. The offset. The second value is for an overflow. So for the first one, for the first character, nothing overflows, right? So we're done there. And then we set the offset for the next character and move on to the next character. But for the second one, there's a little bit of an overflow. So the first thing I do is I write this tile, and I commit it as finished, and I'll move on to the next one, right? So the second tile, this one here, reloads that character, and then shifts it to the to the left a bunch of times to match its other half, or not half, or its other portion on the other tile, right? So it shifts it off the tile essentially. And then, based on that, it gives out a new offset for the next character. Then we rinse and repeat that essentially. All the while keeping track of which tile we are currently on, and if there's still some space left on the current tile, we do not move on to the next one. We just stay on the current one and make sure we update the the offset. It's possible that a character is exactly matches up exactly to the boundaries of a tile, which would be that. So this would be matching up exactly to the tile if, you know, a row of threes. In this case, it would just simply move on to the next tile without really updating anything after the second draw, after the second one. So, but yeah, so I'm currently working on this one here because of how it's offset and everything. Yeah. Anyway, so the first one, the first go around, the offset should be 0, right? The second go around, it'll be 5 for the second character. For the third character, that offset is 2, and then for the fourth character, that is 7. And then for a fifth character, that would be 0, 1, 2, 3, 4. Okay. For the first character, the shift left is going to be 0, because we ain't going nowhere. It's just at the very beginning there. It's the computer relative branch of assembly. For the second character, it's going to be shifting over like 3, I think, right? Yeah, it's going to be shifting over 3. For the third character, it's not going to be shifting over any, because it's going to be contained entirely within the tile. Then for the fourth character, for this one here, it's going to be shifted over by 1. Yeah. And then the last one, it's not going to be shifted over at all. Okay. So now let's go over to here and see the values that it's actually throwing out. So we're actually gonna open up the watch window over here. I don't know if you can really read that very well, but yeah. Anyway, so the first one is the data pointer. It's not really relevant, I guess, for this, so I'm just gonna get rid of it. Character width comes into the calculations of everything to figure out where the offset should be. This is the current offset, the beginning offset. This is how many times it should be shifting left. This is the current row. We don't actually need that. We don't need to watch it. Buffer index. I mean, I'll keep that in for now. Same with the name index, so I know where I am. All right, just gonna go ahead and reset. And I think it's this one. Nope. Symbol name. Okay. First character. So this one is going to write fine. I know that. Let's go to the next one. The next one I think writes fine as well, doesn't it? Luan Davici, how you doing? Welcome. Yeah, I'm pretty sure the second one writes fine. The third one is where things start to go a little wrong. Because when it's drawing this one, it at the end of drawing this one, is when it figures out the values for the next one, right? Yeah. So I'm looking at this one. So character offset of 2 is correct, and starting off, that's the only value we really have to go by. So the offset and the current buffer index, the current tile. Well, not necessarily the tile. Kind of the current tile. It's at 8 right now, which means it's on the second tile. Is that correct? Yes. Okay, so this guy's going to be contained entirely in the second tile. So it should not have any overflow, and it shouldn't be doing any shifting anywhere. Aside from to the right, the initial shifting. Alright. Alright, loading up 5, that's the width. Store that into the width. Okay. Clear carry. Add that to the offset. Why? Overflow. This is to find the overflow, right. So that is 7. That's actually the next, that's the next offset, isn't it? So I could probably save that here as like next offset, and not have to worry about what's it? Recalculating it later on, like for the next tile or whatever. In theory. Anyway, we subtract 8 and store that in overflow. Now, if this is negative, that means there's no overflow. We got some stuff left. All right. This is all commented out code that I think is wrong. So whatever. So if this is 0, that means there's no overflow, but it lines up directly with the border of the next tile, so the offset is going to be 0 anyway. But if it's positive, that means there's some overflow into the next tile, and it'll show you how many rows of overflow. Well, I mean, I'm sure it does, but... So, like I said, I'm pretty sure I said that I didn't look for it. So there you have it. Goodness, that is a lot longer than what I've got. A lot longer so far. Space. What is this one even doing? So there's dedicated loops for shifting, it looks like. Some rotation stuff. Goodness. I'll look at that later. Let's carry on. Yeah, what I'm trying to do here is hopefully simple and compact. That will work specifically for, well, what I'm trying to do anyway. So yeah, so where we are on the third tile, right? Okay. So this one is it's over here. So this is the first loop that shifts the character over to its starting position. So this should shift it, what did I say? Like by 2? Yes, offset of 2. Load that into X. And it goes through this loop twice. Bam, went through twice. And then it ORs that result with the buffer. And it's going to be 0 on 0 because it's the top row of it. And there's nothing in the top 4 rows. So we're going to go ahead and turn on this other breakpoint. Is it this one? Yes. And we're just going to jump down there. Okay. So the first character has been written to the buffer in its entirety. Load up the overflow. If it's equal, it's even, the tile is even with the next, and it's not. We're comparing it to 0, and if it's positive, there's overflow. Otherwise, there's underflow, which is room left, right? And if there is, good. Load up the width, store that in the offset. That is incorrect because this is already at an offset. So what I need to do is I need to load up the width, add it to the offset, and then restore it. Okay, so that's step 1 then. So that's probably why it's getting stuck in this tile as well. Yeah. Alright, so we're gonna fix that and see what happens. Whereabouts is the sun again? Above tile even. Or above or below? Oh, yeah, right here, okay. Don't remember if carry's set here. We're gonna clear it anyway. Add carry. Add the offset and store it. There. So now, this will add. Oh, this will have 2 plus 5 would be 7. So that'd be the new offset. Yes. Okay. Good. Yeah. Let's go over here. Oh no, I need to go and open up my console first. Thank you for that file. Appreciate that. NES kerning make beautiful. Where is I passed it? Sorting, how you doing? Thank you for being here. Think you found an angle. Is it a cue? Alright, F5, get to where I want to go. Where am I? Why am I here? Hang on. I mean, that's cool and all, but like that was not the right breakpoint. I don't think. How'd that breakpoint get there? I thought I had a breakpoint like way up here, didn't I? On character. Okay, so we're back to where we were. Alright, Tasty, do you have a good night? Thanks for stopping by, appreciate it. The PPU during rendering can only read 1 byte every 2 cycles. The first cycle loading an address latch, the second actually doing the read. Okay. And it's PPU cycles, not CPU cycles. Right. Right, because doesn't the PPU operate 3 times faster than the CPU? If I'm remembering correctly? So if you had a really tight loop that just wrote to the PPU, or not even a loop, just like a straight writes, repeated writes, it would, you know, change every 3rd byte or whatever. So, given fast enough RAM, you can simulate a dual-ported RAM. I don't know what that means. Sorry, Bitchwater. Okay, so we've got the name in there. Let's move down a little bit. Where did I? We're gonna drop a breakpoint there. Bam. 2 processes can hit it at once. Okay. Like similar to memory mapping it, or something different? Am I misunderstanding still? And look, how you doing? Probably. What was Final Fantasy 1 on? It was on the NES, right? Yeah. Yeah, there's a chance they did. Absolutely. Especially if it was earlier in its life cycle. So there'd be something like a page register that controls a window from 5,000 to 6,000, and CPU space that feeds PPU memory. Oh. Okay, so kind of like mirroring it to PPU space then? I think that back then was even harder. Yeah, it was. It was probably a little bit harder because they didn't have the resources that I have here, and the decades of work that people have put into the system about figuring out how it works and whatnot. Yeah, Final Fantasy 1. One player. What's the mapper 1? Okay, so that's the mapper I'm using actually, isn't it? Right? Well, not here, but I mean, you get the idea. AMC 1B2. No, it's not. It's a different mapper. Hang on. What mapper am I using? JW9S, how you doing? Yeah, basically mirror the PPU accessible memory to CPU space. Okay. That'd be kind of neat. Mappers. Yeah, okay, this is the one I am using. I think. No. Yeah, because I'm using the Fix 32. Alright. When did this come out? 1990. Okay, so it is much later in the life cycle of the thing. So it's not completely out of the question that they might have done this in C, but there's a very good chance that they did not. It's older than me. It's almost older. It's not quite older than me. Might need to use a PPL to recover the CPU clock for. I don't know what a PPL is. I assume that's some like electronic discrete component. Phase locked loop. Got it. So I know what those words mean, but like not necessarily together. TV clock. Okay. Okay. I'm sorry for being an idiot. Alright, so we've got the width and the offset. We've got 7 in the register. Store 7. There we go. So 7 is the next offset of everything. Yeah, which actually, hang on, when it was broken before, it had the offset of 5, right? Which would mean, so 0, 1, 2, 3, 4, 5. It was drawing this one correctly, given the information, but nothing after it. Because this one would have been the same as this guy over here, right? The same layout, but nothing over here was drawn. Okay. Well, let's see if this fixes it anyway. So yeah, so we are still on the current tile, right? We're not moving on to the next one. So we need to decrement the buffer index by 8 to move it back to the beginning of the current, or of the now previous tile, the tile we just wrote to. So that's what this is right here. And then we just jump up to the top, or not to the top, jump down to load next. So it increments the index of the lookup, the text lookup, and jump back to the top. All right. So this one should be shifted by 7. What did I say the second one was? The second value that I wrote down here. I probably should have labeled these, you know. Oh, and a shift left. Okay, so let me that way, not that way. There we go. Okay, I wrote it down now. So yeah, so this one should shift right 7 times, and then shift left once. Okay, let's hit F11 on the correct window. There we go. Oh, let's open up that as well. All right, no exit. Get up the width. Start on the width. Add the offset. and -8, and we have an overflow of 4. Yes, that is correct. Yes. Alright, then we're going to jump down to here again. We're checking the overflow. So we have some overflow. It's not even. Comparing it to 0, and it's positive, so we're jumping down to overflow, and my neighbor's making a lot of noise up there. Goodness gracious. Resetting the row. Loading up 8. Subtracting the offset to get the number we need to shift. That's 1. So we need to shift each row once. Okay. So this loads up the data. And shifts. Then saves it. It does that a bunch. Okay. Terminally Nerdy, how you doing? Welcome. I am still attempting wizardry. Yes. Trying to earn my wizard's hat. How you doing tonight? All right, so it buffered those 8 rows. Alright, so now we need to figure out the next character's offset. So this one is based on the second tile we just wrote to. Based on this tile over here. So that's going to be 0, 1, 2, 3, 4. So this should be 4 at the end of everything. So we're loading up the width, we're subtracting the shift, however many times we shifted left. It's throwing that. Okay, that looks fine. Yeah. And then again, we back up the buffer index by 8 because we still have room left in this tile, so we're going to write to this tile instead of the next one. I'm doing alright, I can't complain too much. Can we presume that the PPU clock and the CPU clock are phase aligned? That's a good question. I don't know. Otherwise, we might need to attempt to recover the PPU edges from relation between the PPU RD signal and the M2 clock signal. If they're both off the same crystal, wouldn't they be aligned to some extent? So the PPU would go under some sort of like clock division. Mensley, how you doing? It's all right. It's okay. It. Believe me, I barely understand what I'm stepping through, and I wrote this. I have been working on this specifically getting text next to each other since like last Tuesday or Thursday. And this is like the second or third method I've used that hasn't worked so far, by the way. So I mean, you're not alone there, honestly. They'd have a consistent relationship, but it might not be particularly well aligned. Okay. Frozen Zerker, how you doing? Texas are immortal anyway. Alright, so we back the tile up. Back the index forward up. Go up to load character, and we load up another character. Okay. And which one is this? So this is going to be 0, 1, or yeah, 0, 1, 2, 3, 4. Let's put another one on there. So the next one's gonna be there, the next one's gonna be there, and there. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is whoop, you can't really see all of them, but so this is how many it should write at the very end of everything. So we have currently written that one, that one, that one, that one, and that one. So the next one is this guy here. So again, that's 4 in, and it lines up directly with the edge of the... Well, no, it doesn't, actually. It doesn't. It almost does. It almost lines up directly with the edge of the tile. It's off by 1. So this one's actually going to shift to the left by 4. Yeah. So 0, 1, 2, 3, 4. It's going to shift in 4 because it's offset by 4. My ears are being really loud out there. Holy crap. And then it's also going to shift the other direction 4 on the next tile. Yes, it should. So let's see if that actually happens. So up the width. That's width of 5. Clear the carry. Add the offset from... or for this tile. It's 9. Set carry minus 8, which is the width of this tile. And there we have it. We have 1 row overflow. Okay. So we come down here a little bit. Load the offset and do the shifting. Okay. So then we're going to jump down to after that one. So it's written the byte to the tile now. Or the rows to the thing, to the tile. So it's fascinating that these guys pumped this out like nothing back in the day. Yeah, it honestly is to me too, because they couldn't do what I'm doing here. They could not step through their code by pressing a button like this and immediately seeing the results. What do you think wasn't hard? Gareth Hubal, how you doing? Welcome. How's your day going? I'm doing all right. But yeah, they did not have these tools. Like, if they wanted to test this out, they needed to like grab a chip off the windowsill, pop it in their EEPROM writer, write it out to the chip, pop that chip into a dev cartridge, and then put it in the console, and pray it worked. And if something went awry, if something broke, they'd be like, okay, well, it broke. Let's get out our notepads and calculators and pencils and figure out what happened. Let's step through this code by hand in pencil. Something that I honestly should be doing more of. Good thing, sore throat. Oh no! I'd love to see the tools they used back in the day. I believe the Mega Drive had some reasonable dev tools. The NES, from what I understand, had no official first-party dev tools at all. So any development boards you will see out there are going to be like basically homebrew boards, but you know, backed by a company. Not for basic logic, for NES specific stuff, yes. But for basic logic, they could run an Apple II or the like. That is true. That is very true. Yeah. So for the basic logic, they could have debugged on a different machine, like as Bridgewater said, the Apple II, which has the same chip in it. But if it's like a graphical issue that they're having, good luck with that on the Apple II that doesn't have the PPU on it, for instance. You know, which really does kind of explain some of the things that some of these games do. Like, for instance, no, that's not off. Let me turn that off real quick. I can grab the cartridge. For instance, when I was stepping through this cartridge right here, Barbie, they did some things that I found a little strange by rewriting the mapper configuration like 2 or 3 times per frame. Many more times than it needed to, but if they couldn't like step through it like this, well, maybe they just went, well, maybe it might not have worked the first 3 times or the first time, so let's just write it again, just to make sure. So you know, it's a bit of a insurance or whatever, you know. Not that back in there. Sakanaka, how you doing? I know that Activision used RAM cards for a while for development. That would make sense. You just have a cartridge with a battery on it and 2 chips of RAM. That would essentially be what Infinite NES Lives has done, more or less, with their burnable cartridges. I see if we're going to take this and change no sense, right? Just do it a couple of times. Just make sure, and write it 3 times just to make sure. The only time I've ever seen that game was on an AVGN episode. Is there any footage still stepping to the Barbie code? Oh yeah, let me bring that up. Hang on. So I brought out the Barbie code because, or the Barbie the cartridge, because I actually started writing a tool-assisted speedrun for that game. It's a terrible game, by the way. Where, like, it isn't coded very well, I don't think. I don't think, because I've already found like at least one bug in it. Let's see where Barbie. There it is. Come on. Not the debugger. I don't want the debugger. I want instead the task editor. I want to open up Barbie tasks and scroll to the top here, to the top. Bloop. And make sure my sound is off because I don't really want to. I don't want to listen to it. Okay, good. It is off. There we go. Barbecue? Yeah, pretty much. So this is a tool assisted speedrun. So this window over here, with all the green that's scrolling by, that's all frame-perfect button inputs that I have programmed into the game. And essentially, it's all frame-perfect jumps and whatnot. But yes, this is that game. Is there any footage of me is there any footage of me stepping through the Barbie code? I don't think so. Not really. And yeah, so one of the reasons why I'm learning to write NES games is to be able to reverse engineer other games, right? So I figure, like, okay, so step 1 is learning assembly. That was fairly straightforward. Step 2 is like, okay, I know the assembly now, but now I need to know, like, the system itself and how to write things for the system, how to, you know, encode maps and things. So the best way to do that, I figure, is to, you know, write a game or 6. Maybe lazy isn't the correct word, but man, I'm glad I don't have to think about that. Yeah, right. Pretty much today seemed lazy. Your desk is scratched where your wrist rests. I like that. Yeah, so this is actually an old desk. In the last place I had the desk that flipped around, and over there it's even worse, like really, really badly. The cartridge will be plugged into the console, the RAM will be written, and then turn on the console and run that. Oh, nice! Nice. So they just streamlined that a little bit more then. Only to get Barbie. No, so this I didn't write this game. I was writing a tool assisted speedrun for this. You'll see here in a second the almost right here, soon, right there, and it breaks. So you're not supposed to be able to walk through those, right? So I paused for a second, like, wait a minute, hang on. That collision happened. It didn't happen. QP, Q, how you doing? Welcome, welcome. Thank you for the raid. How's your day? So that collision didn't happen. I'm like, wait a minute. Okay, logically, I can think of like why it didn't. Like the top of that. So it's made up of a bunch of sprites, right? So if we back up a little bit, so the top of that is going to be a sprite, right? The top of the water is going to be a sprite, and I guess the collision only happens on that sprite. Cool. Collisions are fun. Yeah, right. So like, okay, how do I figure out where that is and how to you know, exploit that more and figure out the specifics of it? So I opened up the debugger in this program, in this emulator, debugger, and I'm like, oh, I don't know what any of this means. So step 1 is learning the assembly, like I said before. Step 2 is learning the logic flow of a game. Because I can look through here and be like, okay, what is any of this doing? RTS. Okay, that was a subroutine, I guess. Sure. I'm bidding something, but why? Why am I bidding something, right? What is that even? What was that one? Where did I go to that? Bit store. Like what? Look, just looking at this, I'm like, well, what's going on? What's happening? But now that I've started to write some game stuff, and I'm even using the same, just by pure coincidence, I'm using the same mapper that that Barbie is using. So looking at this, I can go, oh yeah, that's mapper stuff probably. It's writing some mapper configuration. So DFF. Let's figure out what that is real quick. So this is the same mapper that Barbie is using, right? So the way this one works is it how does it work, actually? I forget. It shifts things off and writes them to specific addresses. Yeah, MZ1. It's one of the earlier mappers, right? So it writes to 2 separate registers. Control. No, I want. What is it? Unlike almost all mappers, MSC1 is configured through a serial port in order to reduce pin count. SPU 8000 to the end is connected to a common shift register, writing a value with bit 7 set to any address, and that clears the shift register to its initial state. Yeah. So you need to write to this register a bunch, right? So that's a telltale sign of any. I just realized you can see up there. Telltale sign of any mapper stuff, right? So depending on where you write, it means different things, essentially. So, this is first load register, reset the shift register, yeah. So if you write to between these addresses, it sets one of these things, right? What's writing to here? Is writing to DFF. So it's writing to this address right here, so that is selecting the CHR bank, the lower CHR bank. That's what this is right here. This right here, B00, it's going to be selecting the upper bank of CHR. But I only know that because I've written code using this specific mapper, you know, so I know what to look for now. KL6, how you doing? Oh, K6L2, how you doing? Like embedded, yeah, this is kind of like an embedded system. I'd say that. Is there still a need for assembly programming? I'm sure there is, but I have to ask. Yeah, so yeah, like K6 has said, mostly embedded programming now, or retro programming if you're gonna do it. For embedded systems more than most other things. Yeah. For making games on 8 and 16-bit consoles, computers, yes, defo. I mean, there's that too, but resource constrained embedded for compiler backends for certain low levels of programming. Yeah, so it's out there. It's not. That made me nervous for a second. I don't know why, but it did. That's just Steam being disconnected. No, whatever. It's not nearly as prevalent or needed as it used to be, because like back when this thing was released, if you wanted to write a game for the NES, especially early in its life cycle, you had to write in assembly. Like there wasn't any way around it. Yeah, so like I've mentioned, you can write C for the NES, but it's not really as efficient, and there's actually a bunch of overhead for C. That the 6502 does not have any. Let me rephrase. The 6502 cannot accommodate the C coding structure natively, so it has to work around and inject some more overhead to get it working the way you want to. How much does an assembly programmer compared to, say, C++? How much make? I don't know. I don't do this for a day job. I'm sure it takes a minute to find someone. It depends. It all depends on your field, really. You can even write C++ with the 6502. I think Jason Turner did it. Yeah, I wouldn't recommend it for anything commercial, especially. But yeah, absolutely. I mean, yeah, as long as you can get it to a bytecode, you can figure out a way to write something. Excuse me. A NES game in pretty much anything. Just got the Steam pop up. Did I say hi to you, Frozen Zerker? I don't remember. I think I did. Yeah. I need 2 seasons of overhead stat. I can go get it. I can get Go to bytecode. I don't think Go would really work very well on an NES because of the design of it. Like the Go routines and all that won't really work well because there's an entire like engine around the Go routines that's designed for multi-core systems that the NES is not. Also, you need to use assembly on an architecture before you have anything else for it. Yeah, pretty much. JavaScript. I mean, it's possible. It is. I'm sure it is. Do I recommend it? Absolutely not. But I mean, that has stopped anybody before from writing things in JavaScript? Absolutely not. How you doing, excellent? How you doing? Welcome. Ross might have a chance, will it? Fletcher King, how you doing? We'll just go single-threaded. Run everything in a single thread. I mean, that's essentially what the NES is single-threaded. The Voden, how you doing? The Void NN, how you doing? Excuse me. BF interpreted right games in BF. So that actually wouldn't be that hard to translate things into BF, and writing an interpreter for that on the NES, I don't think will be that hard either. In fact, if I ever get a keyboard for this thing, I might try that, because I think that'd be fun. And I've already written an interpreter for BF in Go. So yeah, if anyone wants to send me one of the Family Basic keyboards, hook me up, no? I wrote a 1986 Counter-64 game for web and mobile in oh no. Just needs a quad-core CPU to run instead of an 8-bit 1 MHz CPU. You're right, just several orders of magnitude more powerful to run the exact same thing. Alright, you have a good night. Thank you for stopping by. Appreciate it. Appreciate it. Is there already an NES interpreter for that? Is it on a cartridge? Is it on a cartridge? Because I would like to get that cartridge as well. I think it's doing some homebrew 3DS development at some point. It's more complex system than that. So yes, and I'm pretty sure that the 3DS development is like strictly C++ and above, isn't it? And they would have some sort of first-party development environment, or not necessarily environment, but development tools for the 3DS. Oh my goodness, what is this? Is it really? Oh, that is fantastic. That is fantastic. How do I need a keyboard for this? Read operator not supported. That's fine. Okay. All right. Let's save that. Turn that off. C for homebrew 3DS. That sounds about right. More than one, actually. I wouldn't be surprised. Where is my adapter? Keyboard is about $50 via eBay at the moment. Alright, that's not too bad. I did just spend like about $50 on a mount from eBay, so I might have to wait another week or so. Come on. So there's this TV that I have that, like, the case on it just crumbled. So I need a mount for it, so I bought one. And I bought one a while ago, and it was the wrong size. So I have to buy it again, but the correct size this time. Alright, over here. I'm fine with C++ and above, not as hardcore as you remember. I pitch C++ as the, quote, low-level language I work with on a stream. Instead of F# for the high-level stuff. Yeah. Anyhow, they are. Yeah, they are. What's the NES stuff for them? Alright, so let's see. Game.NES. We're not gonna. No, it's not gonna be game.NES. NES. There we go. Maybe something a little bit better there. Copy. Over here. Pop that in the homebrew folder, I guess. Paste that there. Look up. And. Bada-boom. Got to say, no worries, it's fine. Currently writing some C-lib and jumping between streams to finally just. And your season. Oh, thank you. How's your hacking? It's going. It's going. So what I'm working on tonight is kerning for lettering. So I have this font here, right? And you'll notice it's all aligned to these squares, which are all 8x8 pixels. So instead of having a monospace font, I want a variable width font, essentially. So I want to kern them all correctly. So that means like taking the H, right, and putting the I right next to it, and then later on coming over and putting like the Y right next to it or whatever, right? And manually, or not manually, but like automatically constructing the base tiles that I need to use to draw anything on the NES, essentially. Because I can't draw pixel per pixel on the NES. I have to go through the tile system. I need to go through the tiles and do it that way. But welcome. I'm glad you stopped by. Thank you, Gareth. Appreciate that. VWF. Sure. How you doing, Mouse? It was Mouse, right? Am I remembering correctly? Ah, yeah. Variable with fonts. Yes, thank you. Okay, thank you. Jojo, how you doing? Welcome. Welcome. All right, so I'll turn that back on, and then I want to come over here, and I want to have a look at this. Actually, I want to have a look at this. What is this? 2019. This is like brand new then. Start. Oh, it doesn't actually show me the code. That's disappointing. That's disappointing. I can't see the code. So like I would assume like it's a interpreter for it, right? So there is the code in there somewhere. But oops, I turned it off and I didn't actually change my screen. There it is. Now. Yes, they do actually. They do have variable with fonts. And they use a method similar to mine anyway, I'm sure. But in order to have the variable with fonts, they need to have CHR RAM. So they need to be able to write to the RAM. Normally, or originally rather, I should say, the two chips on the cartridge were... There we go. Here's a good example. Well, no, that's probably a bad example. Are these... What kind of screw heads are these? You know... There we go, this one works. And typically there was only about like two chips on these things, right? So if, originally they were both ROM chips, so unmodifiable. Eventually they did drop a RAM chip on some of them if they had the money and the need to use it. So they could compress the tile day a little bit better and be more versatile with it. A good example is Battletoads, actually. They use CHR RAM, and they use it very creatively. And that's how they get the parallax working in a lot of their levels, where the background is moving at a different rate than the middle ground, which moves at a different rate than the foreground. But there we go. So yeah, just about, or the vast majority of NES cartridges just have this inside. So this one right here is the CHR chip that has all the graphics data on it. This one right here is the PRG chip that has all of the program data on it. Yeah. And then the little one right here, on the top would be the mapper chip that controls memory mapping things, and then this guy over here, the last one, is the lockout chip, which is the DRM essentially on the NES. Just walked back from the ice cream place. All right, did you get anything good? RHDN and his 240p test demo do, for example. I don't think I've seen that one. Action 53, Nova Squirrel, anything Teeples does. Yeah. I meant like the older things anyway. The commercially released licensed games at any rate. Because there are a lot of things that are homebrew that use RAM. And one of the boards out there, GT ROM, I think, is a massive RAM board, isn't it? Isn't it? Like, doesn't it have like memory mapped name tables? Which I don't think you see at all in commercial games. So you have like two separate full banks of name table space. I'm not aware of any commercial era examples of NES. Really? I'm looking a while back. Really? Because I'm pretty sure there were. There had to have been. In fact, wasn't it like Zelda 2? Didn't Zelda 2 do some of that? I thought it did. I thought it did. Maybe not strictly variable width, but I know it used RAM. Yeah. That makes sense. I tried to translate a JRPG once upon a time, but trying to fit the translation to the small text space is brutal. Yeah. Yeah, so that's always going to be difficult. Translating old games and getting them, like, getting a patch. Because not only, like, is it a bunch of text data you got to put in there and figure out where it is and figure out the decompression format and all that. There's a very good chance that whatever you're translating into doesn't fit into the space that you need to fit it into. Could you imagine if modern programmers were as efficient and skilled using modern consoles developed back in the 80s? How amazing would games be? Goodness, it would be different. It'd be a lot different, I think. A lot of SNES games had it. Yes, so the SNES, it didn't have a dedicated CHR-ROM, as far as I'm aware. It had to copy everything to VRAM. Yeah, it had to copy everything over. Of course, it had CHR as a standard and general part. Yeah. Afterburner 2 used ROM name tables. Afterburner... That's one of the plain games, isn't it? Isn't it? Hang on. I need strict safe search on. It is! Jeez. Yeah, this game, I can't imagine programming on the NES. Genos, how you doing? The Epic Unknown, how you doing? Japanese font when? I mean, I could just swipe the font off of the study box for that one. Because there's a massive font table in there for that. There's some commercial games with never having it. Oh, really? A few commercial games use text-rendered CHR RAM, but I couldn't find any that were variable width. Got it. Fandaxu got it, for example. Fandaxu did it, for example, was very handy for kanji. Yeah. So if you want to do like a lot of kanji text, that's more than just like a title screen or whatever, you're going to want to use RAM, just because the sheer number of kanji are not going to fit easily or nicely into character ROM, or even if it does fit nicely, if you have a string of, say, 4 kanji, there's a good chance that those 4 kanji are going to be in different banks of memory that you would need to, like, swap out, and you can't do that for the same scan line. I'm sure they would bring raycasting back to modern consoles. Yeah. Anyway, now that I am sufficiently distracted, let's just see what happened here. Let's I'm gonna turn off these breakpoints, all those, and I have a breakpoint set on the end of writing data to the PPU. So go up. Okay, well I got that one too. Bam. All right. Not quite. I mean, it's close. Like 0, 1, 2, 3, 4. So there's 4 of them on screen. 1, 2. 1, 2, 3, 4. Oh, but that is wrong. Okay, it's not getting the spacing correct. Am I doing the math wrong then? I think I'm doing the math wrong. So this one's fine. The first one's fine, right? So this tile here is a tile in its entirety. Yeah, a tile in its entirety. This guy here is not in its entirety, so it's overflowing into the next tile. It should be overflowing by 1, so it should be ending there, but it ain't, for whatever reason. Instead, it's heading further over. You know what I'm going to do? I'm going to, I'm not going to align these to the bottom. I'm setting a line to the top. Like that. Go ahead and save that, but I'm going to grab those, put those on a new layer, then hide the layer, and then save. You know what? I'm going to move all these guys up to the top too. What? Oh. Oops. Yeah. There we go. So at first glance, I can see, or from the first loop, I could see where it's doing the things. Let's do that. Let's come over here, remake it. Over here, reload that. You know, I need to remove that. I need to remove that. Hang on. So I don't have to scroll for 6 days. Oops. Well. There it goes. Alright. Now then. I hit the wrong button. Okay. Well. Or rather, I needed to look for the... that's right here. Load character. Okay. First character. With the 5, no offset, no overflow. Okay. Go down to here. Not even, no overflow, we're doing underflow. Load the width, add the current offset, store that in the no offset. Good. Okay, so that part looks fine. Right? Because it is... Well, it's gone now, but I mean, it was spacing them correctly. It just wasn't dropping the first tile correctly. Alright, next tile. Now this one is where it starts to go a little wonky because it doesn't shift to the left correctly. So let's go down to the width. Load up 5 so in the width. This isn't going to change for any of them in this run, but that's fine. Click carry, add 5 for the offset, and then subtract 8. And we have an overflow of 2 tiles. Yes, and the 2 tiles, one of the two tiles, 2 pixels, 2 pixel columns. Yes, one of them has, excuse me, one of them has a pixel on, and the other one is the background pixel. It's still 2 pixels though, because the padding is included in that. The padding between the characters, rather. Alright, so this part works fine. What doesn't work fine is the second half over here. So, where's my calculator? So at the end of this, it should look like 80. We should have 80 in A before we write the row to the buffer, right? Alright, so we have some overflow. Cool. Reset the row. Load up 8. Set the carry and subtract the offset. That's 3. So we need to shift it by 3, I think, right? I'll turn that back on. So that's this guy here. Let me go ahead and okay. So that's this guy right here. So 1, 2, 3. Yes, we need to shift it by 3 that way. But we're working on this tile here, so we're going to be writing those bytes essentially. They're actually going to be. Hang on. Let's go ahead and move these up to the top. There we go. Yeah, so I'm going to be writing those bytes to this tile here. Now, these don't exist yet, so those will be happening later. This one already exists. Okay. Bring this up. Store that in the... Come on. Store that in the shift. Okay, shift over by 3. So we have F0 loaded up first, right? Yes, because it's, yeah, F0, and then we're going to be shifting it 3 times, so it should just be 80 at the end of that. Eight? Okay. It stores in the next buffer. It just stores it, doesn't OR it, because there shouldn't be anything in that overflowed tile yet, right? This is the first thing that we're writing into it. And then it does that for all the rows. 5, 6, 7, and there we go, 8. Alright, so now now we need to figure out the next character's offset. Actually, I wonder what happens if I go back up to the top. Then we'll figure out why. We're going to put that to be 0. We're going to just exit right there. So I only wrote 2 characters. I want to make sure that these are correct. Because it could be that something else down the line is screwing it up, or overwriting it even more, right? So now let's go to the end of the write buffer. Bam. It only wrote one of them. It didn't write the other one. Why is Sakura subtract 8 instead of 7? Where? Let me put it up over here, actually. So do that in a few places. Here? Subtract 8? Or here? Or here? Because these are for the tile, the buffer indexes. So index 8 is the first row of the next tile. Because it's 0 indexed. So if I subtract 8, I get back to the previous tile's first row. So for the first time this runs through, that would be 0 essentially, which is the first byte of that. As for, let's see, what was that? Let's compare to Y. For this here, this is for figuring out the number of overflowed columns, just like in general. Because of how everything's based, it's all base 0, not base 1 or anything like that. And the tile is 8 pixels by 8 pixels, so that's why you're seeing 8. Yeah, so the tile is 8 pixels across and 8 pixels down, so it's got 8 rows of 8 columns. So I'm subtracting 8 here, for instance, to get into the domain of a single tile and figuring out overflows and such. So up here somewhere, where is it? There's the first one. Okay, so the first one here. So we load up a width of the current character. We're storing that into width to store it to look at it later. We're clearing carry and adding the current offset. Now on the first time through, it's going to be 0, so we're just going to be adding 0 to this. On the second time through, it's going to be, what, 5? So this will be 5 for the second character. Yeah, so a width of 5 and an offset of 5, so this is, say we're on the second character, is going to be 10. Now 10 is greater than 8, so you can't fit all that data in a single tile, because one tile is only 8 pixels wide. So to figure out the overflow, we subtract 8, right? And we store that into the overflow. So that's just how many past 8 we have. we have to write, right? So that's what's in the overflow variable here. If this is positive, there's overflow. If it's 0, we line up directly with the next tile. If it's negative, we do not have an overflow. We have underflow, or more room on the current tile. And this is just transferring an index to a word offset, looking up some tile data, the actual data that we can write into the PPU, or we're going to be shifting around and then writing to the PPU. And then we have two row loops. The first one shifts it right, and the second one shifts it left. Shouldn't the carry remain clear then? No, not for subtraction on the 6502. So for addition, you set the carry, or for addition, you clear the carry. For subtraction, you set the carry, because of how the math works with it. Yeah. Because it's 2's complement math. It's not standard math, if you want to call it that. I don't know. It's not math that we're used to with modern languages. So positive and negative are represented. I don't even know if they are representative. I don't know if under the hood everything is 2's complement. I don't know, because that isn't exposed to you in most languages. In most languages, your number has a sign, and that's the end of it. Here, for 2's complement, so this isn't very large, actually. You can't really see that very well. So let's just take the number 1. It's just, you have a 1 bit. For 3, it's 2 bits at the end. But if I want to do -3, I OR this with FF, right? So or exclusive OR it with FF. Bam. So -3 is FC, right? -1, or no, it's actually F. No, it's FD, isn't it? Hang on. Because 0 is, well, 0. -1. Well, ignore all the others. But -1 is everything set to 1. -1 again. -2. Yeah, -1. -1 again. -3. Then 4. Then what? 5. So it's like an inverted kind of math thing. The sign and unsigned is represented by highest bit of a number. Yes, but it's not like just setting that bit means it's negative, right? So if I have 2 here, right, and I want to make that negative, I can't just set the next bit and make it -2, because as you can see, that ain't really it. That's a different number there. This is a 64-bit number, but the same principle applies. So I can't just set the bottom bit to be the top bit rather for the sign, because yes, it does represent the sign in this case, but it's not the number you think it is. On the 6502, the carry is inverted to do a borrow, so you set the carry beforehand, which represents no borrow. Right. Thank you. You could explain it in a way I could not. Because I am bad at explaining math things. Because honestly, I barely understand them myself, which is why we're stepping through code that can't add. So you say only if it's signed, the variable is signed, but on the level I'm working at, the processor doesn't know or care if it's signed at all. It just sees it as a string of 8 bits, and depending on whether or not that the highest bit is set, it sets a flag, and you can test on that flag if that number is supposed to be negative, or you could not test on that flag. So it's really all up to interpretation, and yeah, in interpretation, the branches you use, the processor itself doesn't care at all whether or not a number is signed or not. It's all up to how you interpret that. to the most extreme actually, because everything here is just numbers, and it just depends on how you interpret those numbers. Perfect example. I'm gonna use this one over here. Is if I go to the top here, and I open up this. No, not that one. This text. You know, I'm gonna open up another one. Or no, I will, so I can actually see it in the disassembly here. So this right here is just a bunch of text, right? Some strings, the text numerals here. So this is a bunch of 4s, a bunch of 3s, a bunch of 5s, a bunch of 2s, a bunch of 1 through 8, right? They're all null terminated or terminated by a 0. Now in ASCII, like it'll shit, what's it start like? Not 30, because 30 is A, I think, isn't it? Or no. No, it does start at 30. So these would be 34s, these would be 33s, these would be 35s in hex, right? This is all be 32s in hex. This would be 31 through 38 in hexadecimal. But it's only those numbers. There's only that value, just because that's a standard that is agreed upon. However, I can change that to be literally whatever I want. In fact, I do just that. So up here in font.map, I am saying, no, really, 21, the hex 21 is really 0. That's what it's going to be. Hex 1, 32, 31 is really hex 8. It's just going to be hex 8 now, because that's what I want it to be. And then, so I come over to my disassembly here, and open up my memory viewer, and go down to, I think I put this in the second half of it, so that's C0. Yeah, so this here is the font data, so this is all pixel data. This is a bunch of addresses. These are widths, and here is the text right here. So you notice B0, or 0B rather. That's not 4, but it is because I said it is, right? It's not the normal representation of 4, but it's 4 because I say it's 4, essentially. So everything is you know, determined by how I interpret it. Sign and magnitude. I mean, you know. This column makes it sort of transparent, not carding this easy. Sort of, yeah. So two column actually makes things a little bit easier. You don't have to really worry about too much. If you say, "Hey, this number is signed," and you use its highest bit to see if it's a sign. Yeah, pretty much. It sets statuses in the register, and it's up to you to check those to see if that number would be signed if you cared to check. Yeah, that's the gist of it, really. But yeah. So in fewer words, when you add on a 6502, you clear the carry, and when you subtract on the 6502, you set the carry. Unless, of course, you are adding or subtracting a multi-byte number, in which case you would clear it once at the top and not clear it between adding the bytes, so you can add over that carry. Or subtract the borrow, depending on which way you're going. Yeah. Exactly. Yes. Alright. So, what did I have wrong here? Oh, right, it just didn't write it. So, why? Windows, why do you do this to me? Like, why every once in a while do you just, like, decide to not register when I lift up my mouse button? So we're gonna trim this down to just 2 of them. So I'm not gonna be modifying any of the processor state while it's running. Instead, I'm just going to trim it down to 2 characters. I'm gonna work our way from there. What do you mean nothing's gonna be done? Oh, because I didn't add that to the make file, did I? Yeah, I didn't. That's better. Turn her down now. Mr. Morrow, how you doing? Nice one. Thank you. Thank you. I actually worked a bit on getting the syntax highlighting done correctly. It's still not really correct, but it's better than the default assembly syntax highlighting for Vim, because it's doing it for like x86, I think, which is not what I'm working on here, and I wanted more colors, so yeah. Yeah. Oh, and Homebrew, if you are still there, I did see your changes to this to the color scheme, and I haven't really gotten a chance to look at it yet. Thanks for asking. That's good to hear. That's good to hear. All right, so I reassembled. So let's go over here and reload it, and just let it run through once. Okay. And it did not write the second one at all. It didn't write it at all. Okay. Why? We're going to have a look at the RAM during this. So the RAM was cleared at the end of that write. So let's over here. All right. So it is not the buffer that's breaking. It is the generation of it. Wait, no, hang on. So here's one tile, and here's another tile right here. Wait a minute. Is it not writing all of them? It's writing them incorrectly? Alright. Out of 0, store that there. Fine. The top of the buffer. 8 of those. Second plane. Cool. Back to the loop. Buffer plus 16. I thought I fixed that. The buffer's wrong. Wait. Yeah, no. Let's add 8 on that, don't it? So this math was way off. Way off. Compare x to 0. No. Compare x to 70 something, right? 167. What is that in hex? You know, A7. The trick's in. Am I assembly yet? Yes. Wait a minute. It censored that? Censoring's out of hand. Thank you so much for the second month of subbing. The second month on Tier 1. Really do appreciate that. How you doing? How's your night going? Alright, so A7, which is friggin' 167. Okay, what's 28 times 8? Wrong. Huh? What am I even... Okay, No. It's 16 times 8. 80. Yeah. 16 tiles, 8 bytes per tile that's in the buffer. That's something different. That is something different. That is for clearing the buffer. You know what? Yeah, let's do that anyway. Let's do that anyway. Fine, whatever. Compare x to not that one. Oh, come on. Not that one. We're gonna compare that to 16 times 8, which is gonna be the same thing. Okay. So there's a decent chance then that it was just the buffer screwing up. Because I wasn't double checking the buffer versus what was written to the PPU. Decimals, decimals. Alright, so you're seeing here buffer 0, 1, 2, 3, 4, 5, 6, 7. That should be 8 through 16. 15. Next loop. So add 8 here. 8 through 15. Good. Oh my goodness. That's correct. Was it really just screwing up the buffer? And writing every other tile? Oh my goodness. Have I been, like, looking at the wrong issue for the past 4 days? One, 2, 3, 4, 5 tiles. 1, 2, 3, 4, 5 tiles. One. Two. God. 3. No wonder it didn't work. My math was right. I just rewrote it 16 different times, differently, but I guess it was still correct all those 16 different times. I was just writing the wrong thing to the PPU. My right buffer code was broken. My God. Oh. Okay. Okay. Son of a... yeah, apparently. Not that, that's not the one I wanted. Yeah, so much can go wrong, and so there's two kinds of errors that you can really get. There's ones that are like almost right. They're so close, but something's not quite right, and you can't quite put your finger on it. But so it looks mostly correct, but it's not quite correct. And that's what happened here. It looked mostly correct, but not quite. And then there's other times where, like, everything's working fine, and then all of a sudden, like, your screen just has a seizure, and you're like, oh dear God, what happened? Those issues are easy to find and fix. The other ones, not so much. Excel, how you doing? Computers are not garbage proof. If you tell it to walk off a cliff, it will walk off. Yes, it does exactly what I tell it to. Yeah, it does what I tell it to, not what I mean. Yeah. So I'm looking at the timing now for these guys. So I'm watching that yellow line at the bottom there. Let's see where that actually goes. Let's. Oh, we have a breakpoint down there. Uh-oh. Oh! Oh, I didn't want to... I want to do that down there. That one. Okay, we're gonna... What are these other breakpoints? I have 2 set that I can see. Where's the other ones? Like, where's this guy? In palette data. Okay. What? Remove that. Where's this guy? Location. Non-existent. Okay, remove that. Excuse me. So far, so intermittent headaches. Oh no, I'm sorry to hear that. Headaches are never fun. Never fun. This is, again, in the middle of nowhere. Okay. This guy's probably in the middle of nowhere as well. 8.6. Yeah, it's beyond whatever. Okay, so we're just gonna enable the, what's it? The marker for those? Gonna close out of that for now. They won't keep that open. Over here, though. Close that. Go away. Reload. Okay, write buffer is starting at scanline 241? 241, yes. I'm going to go to the next one. This is after everything's written. And look at that. It writes 16 tiles entirely in NMI, which is beautiful. Understanding signed ints might be very helpful. For example, in a game engine, you might want to check if you're out of the world boundary. But you could say, hey, let's look at X and see if it's unsigned, and your check reduces just to just that. Yeah. But I guess compilers nowadays are smart enough down to... Yeah, compilers today are smart enough to optimize for that kind of thing. Absolutely. Yeah. And compilers will take care of multi-byte integers for you. On the NES, you have to manually manage your multi-byte integers. For instance, in C, I++, it increments it. Doesn't matter what size of the byte it is. It can be an 8-bit byte. It can be a 32-bit byte. It can be a 64-bit byte, or byte number rather. 8-bit number, 16-bit number, 64-bit number. Doesn't matter. It's just the same syntax. In assembly, I have the increment keyword, or instruction rather. This guy right here. That works on just 1 byte. Now I don't know if I have it on here. Oh, I do. Okay, here we go. So addresses are 2 bytes in 6502 assembly. So you can get between 0 and FFFF in your address space, right? 64K, give or take. So yeah, so it uses 2 bytes for an address. So to increment that address, I increment first the low byte, which is, in this case, the first byte. But if that rolls over, it just rolls over, just that 1 byte. It doesn't touch the other half of the address. You have to check to say, hey, did we just roll over? And if so, we need to increment the 2nd byte of the address. Botfelk, how you doing? For what it's worth, there's computers where a byte is higher than 8 bits. I mean, you're not wrong. I don't think they're nearly as common anymore as they used to be, though. But yes, there are, were, anyway, computers that did not have the typical 8-bit bytes. Yeah. Yeah, even a UN512T that spans 8 64-bit words. Good lord, it's easy in C. 512 UN, jeez. That's a lot of number. Actually, hang on. That's 512 bits. That's more memory than 0 page. So that one number is more than I have for 0 page. It is the 0 page and the stack combined. That's how big that is. For one number. Oops. I misclicked. For a single number. That's it right there. It's a long number, alright. It's a long number. That's probably why programming languages defines fixed bits instead of bytes. I mean, yeah, I can see that, absolutely. Yeah. That, and it gives you a little more freedom to say, like, if you really wanted a 4-bit number, you could have that. In fact, my main game uses 4-bit numbers. The runner game over here. Let me bring it up in here. So this is my main project for anyone unaware. This is the main game I've been working on since like October or so. Oh shit, come on. Video size, it's slowing down a little bit. So these high scores, these numbers here are all 4-bit numbers. So if I have a look in, not that one. So I already have one of these open, and it's hating me. There it goes. we're gonna close some windows here so it doesn't hate me as much. Okay. So if we go down to 6,000-ish, yeah. So here are the numbers. The first 2 bytes are the seed. So you can see 31FF, 31FF, 911B, F69E, yada yada yada. The numbers over here, however, are 4-bit numbers. So B should be 5, right? No, 4B. Guess decimal. Let's that is 75. Okay, maybe I'm a little off. What is that? I could have sworn it was 4-bit. Something like that. You get the idea. This 4-bit would have been like that. Oh, yeah. Okay, it is 4-bit. Is it? No. I don't know. I don't remember anymore. I don't remember anymore. Yes, 4-bit base 100 numbers. That's what it was. Or no, excuse me, 8-bit base 100 numbers. 8-bit base 100. Yeah. So once it rolled over to 100, it would increment the next byte. Yeah. So it was a different base, not a different bit width. But I did at one point, I think, try out or mean to do 4-bit numbers. But that fell through because the examples I found all used the decimal mode that the NES does not have, so I couldn't actually use that one. But yeah, so this is the game I've been working on for a while. Might as well just show it off now. So yeah, I've been working on this since like October or so. But this is my main game. Wrote this entirely in 6502 assembly since October, or from October rather. And I have done the vast majority of work on this on stream. Only a few things off stream. And the only art I haven't done in this are 3 things: the player character you see on screen, those garbage cans, and the truck. Eventually, here, if I can get them all in one shot, I will. Well, that truck, and the player character, and the garbage cans. There we go. So I drew everything but those 3 things. But yeah, it's been a fun journey. All right, back down to 2x, and then thanks. If you're curious about the code, that is up on GitHub. The ROM is not yet. I keep meaning to make a weekly alpha ROM or whatever, test ROM, but I haven't gotten around to it yet, honestly. Text, did I say? Yes. Okay. So this is the standard text file that I'm using, or not? This is the credits data essentially. There's a bunch of names for the test data that I'm using for this. Text, and really, if it just some syntax. Use the correct syntax that I tell it to use, that'd be great. But it never does, because of course not. Why would it? Why would it? Here, I'm gonna load up, turning, uncheck those. Beautiful. Beautiful. And I remember now I disabled the cycling of the names. So we're going to turn that back on. Right here. So now, it should cycle through all the names. beautiful. That is beautiful. The numbers are still gaffed up because let me fix the numbers in the font. Hang on, let me hang on. Grab these guys, get rid of those. Oh, okay, that's what I'll do. I should just like move the numbers to a different layer, but I oh well. Get rid of that. Up and then let's see. Where is it? Credits. Open that up. Copy these. Go here. Paste them. Beautiful. Save that. Minimize. Reassemble that. Not there. This one, reload that. There we go. Look at that. I'm actually going to slow this down a little bit. Half. And video size 4x. See, that is working so much better. So much better. And it's nice to finally, after like a week of working, getting this to work. I'm actually kind of surprised that all these are fitting in 16 tiles. That's not bad. Oh, and I have everything else gray, so I can see exactly where the 16 tiles ends. By the way, this is a bounding box of sorts of the data that I'm writing to the PPU over here. All right. Now in the buffer, it goes down to like 20-something tile, I think, down here somewhere. Like 21 tiles, I think. 28 tiles. It works! Just some guy, how you doing? Yeah, it took a little while. And it turns out that I think most of my math was correct for a few days, but, or at least for today anyway. What's it? The process for writing the buffer to the PPU was incorrect in writing like every other tile. So of course it looked wrong. It was writing every other tile. So once I fixed that, and stepped through that code, it started to work, which is awesome. Yeah. Which is nice. And so far, these are all looking decent. These are all looking correct. Working is better than not working. Yes. M to the M. How you doing? What happens if a string is too long? Things break. Probably. I don't know. So the longest string I have here is 21, I think. Which, honestly, one of these should break. What do we accomplish? Automatic printing? Yes! Yes, yes. So this right here is just given input text and font data. And it's taking that and compiling it, or assembling it on demand, and writing it to the PPU every 8 or so frames. Any chances we can turn this into a mini library for your other projects? Absolutely. That's what I plan on doing anyway. Is just like having these. It's like two functions. It's loading a name into RAM, and then it's reading that RAM address. I might actually streamline a little bit so I don't have to load the name in the RAM. So I load the name in right here. Actually, that goes to what? 20. So this is 21. Okay. See, I load the name into there. And why isn't it clearing this? Buffer 130. De-emphasize. Fade speed. Custom. 8 frames. Goes on to here. 127. Alright, so I don't know what these were, but I guess they were part of a tile. So let's speed up a little bit. Back to normal speed. But yeah, so I think I will format this to yeah, memory overflow. Yay! To be easily includable into my other stuff. So I think at least one of these names goes over that because well, I think I know which one it is too. Darn it. Jojo, this is your fault, I think. Ah! What was that? Zanny Geeks Out! Thank you for the second month of Tier 2. How you doing? I think I know which which name bugs out here and goes over. And that's going to be Jojo's fault, I'm sure. If he's even still here. Yeah, so these names that I'm going through, I'm using these names. Well, yeah, it is. It is. I called it. It is. Okay. Darn it, Jojo. Getting ready to build a roguelike to learn Go. Nice. I'm doing swell now that I've figured out what the issue was. So the next thing I'm gonna try to do, I think, is write 21 tiles per NMI. That's pushing it, because at 16 tiles, it's let's go to the next one right there. It's using up most of that was why did I put it there? No. It's using up most of NMI. Oh, let me turn those on actually. Next one and then next one. Wait, hang on, what is this one? Remove there and turn that one on. Bam, okay. So at 16 tiles, it's starting at the very beginning of NMI at scanline 241 and ending at the end of NMI at scanline 257 out of like 260 scan lines. So I have to optimize the buffer write code a bit. Let me disable these breakpoints. You have some generators written to Go. Yes, I do. Encoding binary is awesome for that kind of thing. Yeah. I usually use it for generating network packets. Oh, really nice. Kind of curious about Risk 5. I am too, honestly, a little bit. I am too. Oh, yes. So, this one specifically does not use that specific code. I am writing a bit of a library in Go that makes that code essentially a lot cleaner. So what Nutrition just linked is this right here. So this is a Golang utility that I wrote to take a bitmap input file and spit out the CHR encoded image file that I can include in the NES without any further processing. And it's kind of ugly, I'm not gonna lie. I haven't touched this specific code in a while because I have broken it out into a library that is not on GitHub yet. I might push that up to GitHub like I don't know, tomorrow, this week, I don't know. Eventually, because that's Golang source GitHub me over here. So I've got libraries specifically for image stuff or file functions and things for image, working with images in the pattern table, as well as the ROM itself. That's my actually like pretty much as ugly and as dirty as Python script. Yeah, so that one that Nutrition linked and that's in that repo is dirty. It's ugly and I hate it. I have since rewritten a bunch of that code I need to clean up the interface, the command interface for it a lot. But again, it's right over here now. So I've made that code into essentially this file right here that has a lot less functionality because it doesn't have any options passed into it essentially. Yeah, so the idea is break out the actual nitty-gritty functionality of assembling the image and all that stuff in the library, and just have to worry about options and like features or whatever in the command itself. The actual what you want to do of the command. You know, I don't like snakes. Yeah, so I might push this soon. Yeah, because I do want feedback on this a little bit, and I figure, you know, more eyes on it can help, can point out some shortcomings that I have. Anyway, I am thirsty, so I'm going to refill my drink. Don't go anywhere, yeah? Don't go anywhere. Such a mess right around my desk. I really need to clean up in here. Torabello. Did I say that right? Torabello. How you doing? Start dot is better than explore. You type less. Well, what do you know? I didn't know that. Thank you. Alright, so let me get the correct number of the longest name. Shall we? Yes, let's. Alright, so where's the X? Right here. Okay. Load a... Oh no, it's an X. No, it's in Y. The index of the name is in Y. The index of the what's in Y? The index of the current place in the buffer for the name is in Y. There we go. So compare Y to longest name. Branch carry clear to plus. Like that. Otherwise, we're storing Y into longest name. Then we're gonna go with the top there. Got res 1. Okay. So now I can reassemble this and watch it break. Longest name is undefined. What do you mean? Oh, capitalization. I guess you should truncate strings that are too long, if that's proper term. That is the proper term, yes. I want to see if I can get all of them in one frame now. My desk only looks less messy than yours because the camera view angle is really thin. Like right off camera, it's a mess. Like over here, it's just a mess of wires. So you're only seeing what, you know, what I'm pointing the camera at, really. Amount of letters isn't good. W characters are wire. You know, you're right. You are correct on that. I don't know why I didn't like think of that, because like the entire point of me doing this is to take up less tiles. So instead of longest name, or instead of just putting Y there, we're gonna load up the character offset. And divide that by 8. Let's divided by 8 is shifted by 3, right? That's not what I wanted. So if we have 16, and we divide that by 8, we get 2. 16. Shift right 3 times. Yes, okay. LSRA. There we go. Okay. So this should be the number of tiles the name was. Right? Clicking keyboard's the only thing that matters. So another thing about that, this camera up here is kind of crap. This one. So you can't really see how dirty my keyboard is. Does the calculator have built-in assembly math, or is that a custom version? Oh no, that's just, this is a standard Windows calculator. It's nothing, different. So I just go to View, and then I choose the one. So standard is the standard one that you usually see. Scientific is one that I usually use for numbers that aren't whole numbers. And then there's the programmer one that I use a lot on stream. And there's also the statistics one if you want to do that. Professor Helmets, how you doing? Programmer mode. Yeah, programmer mode. Yeah, programmer. And yes, the Windows 10 calculator also has this, and it's just organized differently, and I think better on Windows 10. Okay, so let's see what the longest name actually is in tiles. To do that, we're going to open that up, close out of that. Go to that location. Pop that in there. And then, you know what, let's, where's... this right here. Look at that go. Longest name is 11 in hex. $17 tiles. Really? Really? Just 17 tiles? I might be able to write that without changing really anything. Except this. And this. Let's close out of that. We'll keep that open. And let's open up this guy as well. And this guy we're gonna make smaller. Video size 2x. I think that's part of what's slowing everything down. Okay. 5 gets. Okay, so we're at the start of the writing the buffer. My text is not monospaced. Yeah, so some short strings can be longer depending on characters. Yes. What I did to find the longest name is I took the index of the last character tile written to, the last tile written to, and divide that by 8 to get the actual tile number. Bam! Again. Oh. Beautiful! Look at that! Beautiful. It was an extra scan line. And you know what? That's fine. Oh, it's not going to actually write though to the screen because I don't write that many tiles. Where is it? Space, draw text on the screen. Here it goes. 16. No, we're gonna make that 17. So now we will actually see all those tiles there. And the screen shouldn't glitch out when it hits the long one, eventually. I'm not sure what index it's at. Come on. So eventually I might actually use this for my credit stuff. So I'd be able to have almost 16 names, I guess. Unless I change the font to be thinner, so it isn't bold, so... Oh my goodness, it almost fit. Okay, I needed to add 1 to that because it's zero-based, clearly. So let's add another one to that. What is the capacity of those 8-bit cartridges back in NES? So it depends. It depends. So the early games, the Enron games, so all of the launch titles. So let's see. I think this is actually a launch title. Wasn't a while ago, or close to it anyway. I don't know. Do I have what I'm thinking of here though? Hogan's Alley. No, well, that might be launch. Here we go. This is what I'm looking for. Okay, so this is a bit of a special case. So when it was originally launched, these are 2 separate games on 2 separate cartridges. Mario Brothers on one, and Duck Hunt on the other. So these were NROM games, which means that it doesn't have any memory mapped memory in there. So it's just one chip wired directly to the CPU and another wired directly to the PPU. For that, it's a total of like 40k or about 40k, I think. So that's 32k of PRG ROM and like 2k of or no, 8k or something like that. So 48k or somewhere around there of CHR ROM. And that was pretty much it. But what year was that? Early 80s or mid-ish 80s, I think. But eventually, games were like, okay, we need more space than that because we want to make more complicated games. Famicom came out in 83, but the NES came out a few years later. 85-ish, I think, give or take. That's before my time, before I was born, though, so I don't know the specifics of it. So yeah, the very first games, all of the release titles, all of them were NROM games, so they did not have any sort of mapper or anything in them. They were just the really cheap board, 2 chips, CIC chip, and nothing else. So 2 ROM chips and the DRM chip and nothing else. Eventually, companies wanted more space than that. Super Mario Bros. Is basically the pinnacle of NROM before they started making mappers. Yes, they did a lot there with that, with what they had there, with what little they had. Yeah. So the mappers, some of the earlier ones, used cheaper parts. So yeah, that's why the MMC1, one of the earlier mappers, uses this shift register thing where you're writing a bunch of times to the mapper to change the state of things. So let me open up the game I'm working on here, the runner game. So my runner game uses MMC1, and I'm sticking to the official like Nintendo mappers, just so I know that compatibility is going to be high, right? So anything I write can actually run easily. It will be. There's a very good chance that it'll be supported on real hardware, for instance, and any emulator that you're running, because it's a Nintendo mapper, so a lot of games will be using it, right? But if I go down to the bottom here, I think, right? Somewhere. Here it is. So I have to write a value a bunch of times to a semi-specific address in order to write that value into the mapper. And the reason it's set up like this is because the board was cheaper to make that way. Fewer wires and whatnot. So yeah, and the limiting factor of that was cost, essentially. Because, I mean, the technology was there to strap a floppy drive to this thing, but you didn't do that. Like, in North America, it didn't happen. But for the Famicom, there is a floppy drive for that eventually came out. The Famicom disk system. Yeah, so it was more a matter of cost effectiveness for the size of it. So you could put some massive chips in the cartridge, but you'd have to pay for those massive chips and a way to memory swap them into CPU space. 98 StarCraft was 127 megabytes, and now stuff is 30 to 50 gig. Feels like a time machine. Yeah, right. That's one of the reasons I wanted to write for the NES too, because it's so constrained for space. So you can't just like throw a bunch of code at it and not worry about it. You have to actually manage your memory correctly. The console was essentially built to be capable of running Donkey Kong, so its 20-year life is remarkable. Same sort of situation with the Atari, which was built to run Pong and Tank and still lasted 15 years. Yeah, so for the NES, they knew that the hardware that they put in the console would be outdated by the time they wanted to get the next console out, the Super Nintendo, essentially. But they wanted to make it last as long as it could, right? So, and they didn't want to like pull a Sega, essentially, what Sega started doing by selling like attachments and the 32X. This hadn't happened yet in the timeline, but they foresaw that like if we wanted to upgrade the console, they didn't want to sell an add-on for the console. They just wanted the ability to just like they wanted the ability to give that decision to the makers of the cartridges instead. So like, you know what? Let's just wire it in a certain way that allows more functionality to be present in the cartridge later on, right? So that enabled mapper chips, for instance. So on the 6502, there is no multiplication anything. There's no multiplication or division unless you set up lookup tables for that, multiplication tables, or you do it manually yourself. But later on, Nintendo themselves had the MMC5 mapper chip that built that into the mapper. So in order to do multiplication, you wrote some registers to the mapper, and you could just read the multiplication product off of the cartridge. So it's a two 8-bit operands and a 16-bit product on that. That the original hardware wasn't capable of, but because they designed it to be expandable through the cartridge, they could just put it in the mapper and not have to worry about it. So it allowed it to be. That's really what allowed the NES to survive so long, is they could put the extra functionality into the cartridge itself, into the game hardware instead of the console hardware. So yeah. I mean, the modern hardware isn't interesting. It's all about software. I mean, that can be true, yeah. It is certainly less interesting than some things, I suppose. I mean, current generation consoles are essentially all-in-one computers at this point. Well, it's from... I mean, Xpixel, you are correct. They may not seem interesting from the outside. But once you do get into the nitty-gritty of it, you realize that, oh, wait a minute, there's another hidden processor in this processor. What? So that's a rabbit hole you can go down. Yeah. Stroth. How you doing? The FX chip added the SNES carts like Star Fox added 3D. Yes, absolutely. Yeah. So that's from what I understand, true 3D on the SNES with the Super FX card or the Super FX chip. Yeah. Yep. And there's only like a handful of games that actually use that chip. This is like what, less than 5, I think. Yeah, not only chip, but a whole operating system, Minix, on its own kernel, on its own cores, on its own processor in some cases, you know? But it's still all embedded in the same thing. So this is this guy that does some fascinating and really interesting DEF CON talks, or I think it was DEF CON. It was a few conferences to that effect, where he does an exhaustive search through the x86 64, I think, instruction space, and looks for hidden instructions for different processors. If memory lane going there, yeah. Which makes Minix the most used OS in the world. Every single Intel CPU is running Minix. Yup. Which is discomforting. Yeah, it doesn't matter which OS you're running. Yeah, because it's yeah, that guy. Yes, XOR EAX. The same guy that wrote the Mobfuscator, which translates any program into just move instructions for x86 assembly. It's just completely bonkers stuff. Super Mario RPG had a faster clocked version of the SNES processor in the cartridge. Really? Really? For what? For graphic stuff? Yeah, Mobfuscator is hilarious. It really is. It's just like, it's a big bucket of why. Why did you do this? The SA1, isn't that the sound chip? Also super dumb and inefficient. Oh yeah, it's just horribly inefficient. But it works. Yoshi's Island has a whole other 65-816 in the cart. Wow. And it can end it, and the main CPU interrupt each other. Really? Sound chip is the SP. Okay. Yeah, I haven't done any SNES development yet. I say yet because I do kind of want to try it sometime. It's not going to be anything soon, I don't think. I guess it's useful if you really want to protect your... I guess so. Goodness. So I guess they used that as like a decoder chip or some such? Seems there's a demobfuscator available. Of course. But yeah, look that guy's stuff up on YouTube. Because he has another one of what's it? Ways to prevent, or he has it's a talk about preventing someone from reverse engineering your code, and he goes over like the typical protections against reverse engineering is just, you know, obfuscate it and make it really difficult to go through, make it confusing. But at the end of the day, it's still somebody sitting there with 16 cans of Monster or whatever, hating their life, but they're gonna get through it, right? It's tedious, but they'll get through it. So you don't want to take that approach. You don't want to just like wear the reverse engineer down. No, you need to like play mind games with the reverse engineer. So how do we do that? So let's start with the tools that they use. So this one tool, IDA, is a reverse engineering tool. So it disassembles an executable, and it like maps out like the flow control, and it's really fascinating. XOR EAX, this guy. So there's a graph there, right? So okay, can I draw things with this? So he draws a dinosaur in this graph. with Anner, how you doing? What's good? I got things working, which is nice. Yeah, it's still going. It works. The thing works. So he's like, yeah, so I can draw things in this graph. That's awesome. But like, okay, it's a dinosaur. They'll see that and go, oh, that's neat. So how can we make this better? Can I draw a picture, like draw an arbitrary picture? Like with pixels. Can I draw pixels? So eventually he writes a program that modifies itself, right, to draw a picture. So it looks on the hard drive of the machine it's running. It finds a picture, and it draws that picture in the IDA graph in assembly. So that's one of the things, like, oh crap, this program is reading my hard drive and modifying itself to show me my own pictures in the disassembly. And it's yeah, it's a good talk. Let's see. So this one's some reverse engineering of the instruction set, which is awesome. Psychological warfare and reverse engineering. This one right here. That's what this one is right here. Have a watch on that one. That one is an amazing watch. Doing all right. That's good to hear, Anna. That's good to hear. Actually, since we're talking about privacy protection, maybe SMRPG using the SA1 was the case of trying to make it harder to copy at the time when the chip had gotten relatively cheap. Maybe. Quite possible. Yeah, breaking the instruction set. Yeah, is where he introduces Sand Sifter, which is the what's it? The instruction discovery tool, essentially, finding hidden opcodes and things. I don't think I've seen this one. Great Dion. I don't think I've seen that one. But yeah, this guy's stuff is fantastic. It's absolutely fantastic. And I'd highly recommend his talks, because they're very interesting. Very this is Obfuscator demo. Don't need to hear that. Oh my goodness. So these all moves. Anyway, but yeah, highly recommend his talks. I'm still not. It's still not going far enough. So right, I need to add one. So that's not 17. So that'd be 18. Decimal 18. Where is? This is a different file. Okay. Oh, I think originally the 21 number that I came up with was just the maximum number of characters for something. So I figured it's going to be at most that wide, because no font or no character is wider than 8 pixels, and the monospace would take up 8 or 20 something tiles. All right, so we can write up to 18. And then coming down to here, and 18 and 18. Over here, reload that. Over here, reload that. Using define to name all things the same is fun to read. Yeah, but that's just the source code. So what he was doing was a lot of the other way around, so taking assembly and putting it into source code, or reading through the assembly itself, or hacking on the hardware and figuring out, okay, what instructions does this processor take that are not documented in Intel, in Intel's documentation. So yeah, on a 64-bit, on a 60, well, let me back a little bit. On an 8-bit machine, the one I'm working on here, all the instructions are in a single byte, or 8 bits, right? So here's a list of all the instructions going by the value. So break or A, indirect X, future expansion, future expansion, future expansion. But no matter what the operation is, it's only 8 bits or a single byte. In x86 64, they can be a variety of lengths. And to search all of those, so I think like the longest instruction can be 64 bits for the instruction, which is what, like 8 bytes, right? Yeah, it's 8 bytes long. So that's a lot of space to search through. So he figured out a method to search through the entire instruction set really reliably without having to search exhaustively every possible value. Don't know much about assembly. Not sure how. I'm not sure. If I can read. I'm not sure how it would even get started. It differs for all CPUs, I assume. Yes, it differs for the CPUs. So it used to matter a lot more back in the day. Now everything is more or less based on x86. So the processors do differ, yes, but they are all a lot similar than they could be. Yeah, if I can English. This chart has 65 illegal opcodes if you're interested. Yeah, I've seen those. Yeah, there's some really weird ones in there too. They're just like loading up both registers A and X at the same time with one opcode. Various lengths of NOP. One that has a undefined undefined outcome because it uses the open bus in a weird way. Yeah. So depending on like how old your system is and the temperature of like the air around it and like which revision your chip is, you'll get a different result out of this operation or whatever. Not what I want to click on. That one. Alright. So, I don't want that. Let's open up this guy here. And we're going to go down to the right buffer. Oh, those 2 breakpoints. Alright. So, this is the top of the buffer. And let's see how long it takes. Whew. I have barely a scan line left. I use absolute not to skip instructions instead of a bit absolute to avoid changing flags. Yeah, yeah. Like that. Yeah, the illegal instructions are a lot more useful, I think, in patching and ROM hacking. Not necessarily in writing something from scratch. But it is useful knowing that they exist and what they do and whatnot. So yeah, that actually wrote everything and fit it all entirely in one vertical blank. Neat. So let's disable that guy. I don't know what number this one is that I'm not supposed to go into. They use these in homebrews. In homebrews? Really? I thought mostly for, like ROM hacking. Because for homebrews, I mean, you just write the code you want to write. I don't know. I haven't really had a use for them, I don't think. That, and I want to avoid them, too, just for compatibility's sake. Like, for instance, if I ever put this stuff on a cartridge, I do want them to run on, like, the clone systems as well. I still find it amusing to play the old 1001 cartridges because they're obviously botched together. Oh yeah, so it gets corrupted the longer you play since it keeps rewriting its own memory. Yeah, so a lot of those, I think, you'll see a lot of duplicate games, but they'll be like different levels of the same game or something. Most homebrew I know use DevKit Pro. DevKit Pro is C++ lib. Most ROM hacks use the SEM patches to patch games. I don't think all homebrew uses C++. In fact, I would hope they don't. Well, I mean, not hope, but I mean, I would suspect that they don't, just because I don't know. Assembly is a bit more efficient with things on the NES. When you're when you get up against timing limits, the various fuse instructions are very useful. That is true. That is true. If you need to use those two operations anyway. Where is this name? I should have probably like figured out where it was in the index, so I could just like set a breakpoint, a conditional breakpoint, so I could break on that one. Because most of these aren't. There it is. There it is, and it fits. It fits. Darn it, JoJo. That's one of his alts, by the way. It's his alt account. It's JoJo's alt account. But it fits. 18 tiles. 18 tiles and it fits. All in a single frame. I can write it in a single frame. I can't do anything else during the V blank, but I can do that. You know. In fact, I can shave off these bytes as well. So these happen once per loop, right? So I could probably shave off like a scanline or two, right? So I'm pretty sure I still have. Yeah, there it is. Write buffer unrolled. So this right here is basically this, but unrolled entirely. Not using indexed lookups here. So these are indexed to X, right? And at the end of that, I add 8 to X to get to the next tile. Here, I use macros to just make that an absolute address instead. And the loop is in the macro instead of in assembly. So we're gonna write buffer unrolled. And let's see how many scanlines that takes. Because that ain't going to be nearly as many. Oh, because it doesn't clear those. That's why. Okay. Yeah, it doesn't clear those at all. Remove that. Yeah, let's copy this. Yank that. Thank you for that follow. Appreciate that. Paste it down there. All right, and we need to up this to 18. Like that. It's also a question of how much you care about conforming to the model set by original hardware. The illegal opcodes were never used back in the day, since the CPU might have been changed some data on the line, but it never happened. So the sentiment I've often seen is that they're fair game now. Yeah, but I don't think the clone systems would necessarily emulate those very well. So I figure it's safest, anyway, to stick to the official, original model. I assume it would be doable to process Unicode in APIS system. It would. I mean, if you really wanted to, sure. I don't have nearly enough space for that, though. Yeah, it would be really expensive to deal with that. Depends if they use NMOS or CMOS or FPGAs. Yeah, it all depends on the clone system, and to really guarantee essentially that whatever you write works, you use the most common configuration of things. Or not using the undocumented stuff. With FPGAs, the illegals can be directly... They can be, but it doesn't mean they will be. Alright. Right buffer unrolled. So this, I'll be kind of surprised if this works first time, honestly. Whew, that is a lot. Come down here. And mark that as well. Oh, look at that. Okay. Never mind. It did work. Oh, it wrote something. What is that? Wait, oh, no, it just looks a little wonky. That's fine. What scan line is this? 256. That was 2 scan lines shorter? That's not too bad. That's not too bad. So if I really wanted to, I could still shove more, what's it? Tiles into that. What's the size of this buffer that I've got up there? Name buffer 21. Let's add 2 more tiles to that. And see what happens. Oh. XIR, EAX. Hey there, Slash Life. How you doing? Welcome. You think you are losing important skills because software isn't as storage limited like back in the cartridge days? Less incentive to keep size in check. I don't know. It's different things different problems we're solving today. I mean, it's certainly a very good exercise to write software for restricted systems. Absolutely. But it's a different problem that you're solving with this, you know. I guess the important thing is everyone knows about the illegal ones nowadays, so they factor into discussions on archival and such. Too tipsy? Do not listen to me for tonight. I mean, all right, sure. Okay, so we're actually gonna go up to it's a 21, the full 21 to draw to the screen. So there will be a little bit of garbage on the screen at first, but I don't care. So first time around, it's going to have a bunch of garbage on the screen. Like I said, I don't care. And then it's going to write a buffer. It stopped early because I told it to. Go down to the bottom there. Bam. Okay. Wow. Wow. That's surprising, actually. It still makes it all in NMI. 258. Wow. Okay, that's better than I thought it would be. Anyway, I gotta go nap. Alright, Sunny Dear, thank you so much for stopping by. I do appreciate it. You have a good night. I swear, someday I'll drink enough to not be honest enough to warn people about my state of mind. Can you crash the CPU by calling illegal instructions? I wouldn't say no. It's probably possible. But it seems that once again tonight's not tonight. Sorry, it's fine. It's fine, Slash. You're making CHR RAM blasting routines? Yes. There's a halt instruction. Yes. Well, there's a break. Is that what you mean? Halt and catch fire. But only one. Alright. 1.21 gigawatts. How you doing? Gigawatts. Great Scott! Welcome. Welcome. Not break. There's an instruction that will actually halt. Oh! I didn't know that. I didn't know that. Alright. Since they don't refresh the timing register. Oh, well, there you go. Oh, of course it's an illegal one. Okay. So I actually wasn't expecting that to work so well and to fit all into NMI. I was expecting to have to, like, drop into self-modifying RAM for that one. That's kind of surprising, actually. He disappears. All right. Bye. Have a good night. You know what? I think I might grab this font and modify it and make it the thinner version of it. Because I had a different version of this font at one point that was thinner. It was harder to read on the NES, but it existed. Let's see if it's in Git. File tree, credits, history. Okay. Can I? No, just give me. I can't. Why can't I, like, right-click this like I can everywhere else? F15538C442. You jerk. I want that in the filter. There we go. Nope. Okay. Did this one have the CHR? Yes, this one had the CHR. Okay. View history on that now. Five, 6C, 7. Nope, that's not a 7. 7, 3, 6, 5. Not that one. This one. If I rewrite the font, won't my kerning break? In theory, no. That's what I want to test. That's what I want to test, because the width for each character is generated. It's not manual. Aha! Here we go. Okay, beautiful. File, save bitmap. Not there. Whew. That's not a game I can work on stream. No, not even over there. What am I looking at? Code NES. There. There we go. What about white space? Spaces are defined as something. I didn't actually have anything in there that had spaces. I can most certainly put that in there though. All right, so we're gonna close that out with that. Up one. So this is what the font, or one of the older iterations of the Font Wars was. I don't know. I can detect with automatically. Not in the ROM, in the utility that I use to generate the data for it. Okay, so all these need to actually be moved over by one at least to line up correctly. We're gonna actually align these to the top. So this font wasn't as good for a few reasons. One is because it was really hard to read, and two, like none of these things actually like line up very nicely. Like you see, the E doesn't really line up to the top of that. The B doesn't really line up to the top of that. These don't line up. Yeah, so I've improved this one a bunch. Oops, let's I'll do that because we need these guys like that. Yeah. Oh, I can't even like put them up to the top there like that. I need them one off the bottom. Just go. So the bottoms of these fonts will line up. And these guys like this need to go like that. By one. All right. So my utility expects all the fonts to be on or lined up with the left side of the tile. Top or bottom doesn't actually matter, but yeah. And up by one there. Where's that G? There's the G. Let's move this guy down by one. Because that looks better that way. Let's move this guy. And these two. Again, like I said, there's a reason I changed this font. All right, so let's open up the make file. Not main. Make file. And we're going to use font 2, or what do they call it? Font 02. So we're going to come over here and make, if I can spell make correctly. Oh. Oh. Because it doesn't... Yeah. There we go. That's better. Okay. 66 tiles. That's fewer characters. Okay, so let's see how it breaks, shall we? It doesn't. Oh my goodness. What? Holy crap! It didn't break. That is beautiful. I mean, like I said before, the font looks like trash, but it still works, and that is amazing. That is amazing. I wasn't expecting that. I was not expecting that. Yeah, this font is garbage, but I mean, it proves that the code works, which is what I was going for. But yeah, so the utilities that I wrote to do this, they're written in Go, and yes, I did write font to CHR. Yes, that's the tool that takes the font that is laid out in this format essentially. So these guys are at their ASCII values. So this is tile 30, hex 30. So 0, 1, 2, 3, and then it says 0th column. Yeah, so their indexes here line up with their ASCII values, and what the tool does, is it reads this, and it minifies it kind of. So the way that CHR data is stored on the NES is each tile consists of 16 bytes. The first 8 bytes are the first 2 colors, and the second 2 bytes are the second 2 colors, essentially. I think the color numbers I might be mixing up, but that's not the point. The point is, half the color data is in the first 8 bytes, the second half of the color data is in the second 2 bytes. But a font, a monotone font, only needs 2 colors. The bitplanes, yes. It only needs the background color and the text color, the 2 colors. So the second bitplane there can be zeros, because I don't care for any of the other colors, that the other 2 colors in the palette. So why store a bunch of zeros when I don't need them, right? So that program takes that bitmap file, and go to the top here. I'll do this over here. So it takes that and dumps it out into a string of bytes, essentially. So if you look really close, you can actually see that this is an exclamation point, this one's the period, this is the slash, this one's a 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of hard to see, but like you can kind of see them. Like when I scroll down through them, you can kind of see them for a second, right? So it writes these out into just the bytes. So when I expand these later on, right into the PPU, I write these, and then I just write a bunch of zeros for the second bitplane, right? But just that is only part of it, right? So that's that's the tile data. So that tile data is no longer in the ASCII layout, right? So we need a way to translate the ASCII values to the new values, the new glyphs, really. So 0, the numeral, the ASCII numeral 0 is no longer hex value 30, right? 30. Instead, it is now 3. So this file here is also generated by that utility that takes the original ASCII value, or index really, of that character, and spits out the new value for that character, the new index for that character. So yeah, normally, for instance, A is 41, but now we made A 0D, no, capital A rather. Lowercase a used to be 61 in ASCII, but for our purposes that's 28. So when I define those in this file, I define that at the top, so I don't have to really worry about the actual translation. My assembler will do that for me. So even though I include straight text here, my assembler knows to reassign the ASCII values for these guys. So instead of writing what was it, 60 something for A, it writes my new value for A in the actual ROM, so I don't have to really worry about the conversion. Kind of like a table file, kind of, sort of. So font map. This right here, these are all assembler directives. So these are not assembled into the ROM itself. These just tell the assembler to redefine some ASCII, the character map. Mr. Banks, how you doing? I wrote a Chip 8 emulator last couple of days ago and Go NSCL. Really? Nice. Yeah, have drop that on Discord and I'll have a look at it over in the code channel. That sounds pretty neat. That's Chip 8's Game Boy, yeah. So then that's remapping everything, right? So this is the character data itself, the tile data. This is remapping the ASCII to my current one. This right here is a bunch of macro stuff to give me a lookup table for the fonts, right? So these fonts, the actual tile data, are all 8 bytes wide. So indexing that becomes a problem. When I index, I have a single byte to index things for, right? So that's 255 or 56 values, 0 to 255. For a straight table of, say, widths, that's fine. I could just use that, right? Because this is just this table here is just a single byte of the character widths, right? Like the exclamation point is 3 bytes wide, period's 3 bytes wide, or pixels wide. The slash is 3 pixels wide. That's 6 pixels wide, and so on and so forth. These values do include the the padding on the end of the character, the extra pixel. So that'll work fine for this guy here, but for this guy, that ain't gonna cut it, right? So I've got 66 tiles, right? So if we do over here 66 times 8, that's 528 bytes that I need to index, and that is clearly above 256 or 55. And that's ignoring the fact that an index to this data would be a table of words, a table of addresses, which are 2 bytes long. So the most things I could index directly would be 127 different things in that data. So instead, I have to make myself a table of addresses for the different characters, right? So that's what this is. This spits out 66 addresses that point to somewhere in the tile data that I could then index with a with a number multiplied by 2. So as long as I stay under 128 characters, I'm fine with this method. This method will work, right? So yeah, so this is the word table. And yeah, so all this stuff up here is generated, or this text isn't generated, but like everything else is generated. So the char map is generated, the text data, the tile data is generated, the lookup table is generated. This is generated with the the macros, obviously, and the widths are also generated. Oh yeah, and the space as well is right there. So this is me defining the space as a specific character and a specific tile, because the space you can't really easily programmatically define automatically, because it's an empty tile essentially, right? It's just nothing's there. And you know what? I don't even think I don't actually have I don't index it at all. Yeah, so we're gonna down here dot byte. Yeah. 1, 2, 3, 4, 5, 6. No, 4. No. 6, 7. Shoot. Hang on. 0. No, 1. 2, 3, 4, 5, 6. 7, 8. Space. -1 at the end of that. Actually, no, let's not do that. Let's not confuse things. Instead, let's grab this and just put it up here. Space data. Space! And then just do dot word space data. So that right there is the space on the end of things. But that's gonna make things weird. That still wouldn't work. Spaces still wouldn't work. I need to actually encode a space in there. Have a special case for it. Because there is no like tile data for a space. There's just the offset data for a space. It gets things a little weird. How would I handle that? So essentially, what that would do, what a space would do, what I would need to do, is here, I would need to load up zeros always if it's a space. Space just a width. Yeah, space adjusted width. So I don't actually need to do any shifting, really. But I would still need to test for that case specifically, right? So if character is FF, if this is a space, do something different. Now, do I even define the width of a space? I don't think I do. I just define the character itself. I define the character and nothing else. Huh. Alright. Load X. Character from so that's, yeah, the index then. CPX FF. Branch not equal across this guy. Or actually, branch equal insert space. We can put that up here. Like that. And this is going to eventually jump to... I can't jump there. Because that's a local variable outside the scope. Where's load next? Load next there. Just there. Okay, that should work. Alright. So we handled the width. So all that should do is set the... I should check for overflow. And just set the, what's it? The offset for the next one. Alright. Space width. What should it, how wide should it be? 5? Let's start with 5. 5 pixels. All right. Buffer index, longest name. I don't care for any of that. That's exit. Not an exit. No exit. Alright, so we're storing that into character with adding the offset. So load up space width. Store that into CHR width. Clear carry, add carry, CHR offset. Set carry, subtract 8. I'm essentially just transposing what's over here. Okay, so that holds the overflow. That overflow is the next offset, essentially. Even. It's going to be equal. So just store that into CHR offset and go on your merry way. Okay. If it is positive, so comparing that again to 0, branch plus right? To overflow, yep. Okay, so the overflow is again, just store the same thing. Tile even. Overflow. Eight minus offset. CHR left has a number of overflowed columns. This needs to be the number of times to shift left instead. No. I don't care about shifting anymore for this. So I can just I think I can just store that. So let's just do that. Okay, so then this is underflow. Right? Yeah. And this one is going to be load the width. Clear carry, add carry, add the offset. Yeah. This is gonna be. Right? Yeah, so underflow doesn't change the tile. Overflow and even do change the tile that we're on, the CHR buffer index. Yeah. Hispanico, how you doing? Welcome, welcome. So if it's even or greater than, or if it's equal or greater than, it says carry set. So just compare and branch on carry set. Yeah. Overflow or even. Popcorn too hot. How you doing? Yes, they are. Well, the keycaps are double shots. The key switches are blues. Yes, MX blues. Welcome, by the way. How you guys doing? So this, in theory, should work. Or I need to increment the index thing. So it goes to the next character. This should work. It might not. Let's first see if it assembles. It does not. Illegal addressing mode 392. What? Yeah, okay, that's definitely. Uh-huh. Okay, assembles. Never seen anyone that ASCII grind in there. On that ASCII grind. Yes, so this is a bit different than a bunch of stuff on Twitch. There are people that actually write assembly, NES assembly specifically, every once in a while. There's like 1, 2, 3, like 3 others, I think. But no, 4. I found another one, someone else the other day, I think. So there's at least 4 other people that write NES Assembly on stream. I'm not sure if they've done this yet, which is kerning, or variable width fonts on the NES. It's possible. I don't know if they have or not. So let's see if this broke things. It probably did. Texts. All right. Let's add a space in there. Make that. Over here, we do that. And right there, I think, right? Co-location. Yeah. Bam. Okay, what does it look like? F doesn't exist anymore. Beautiful. Arguably, I haven't written any NES on stream yet, but I'm sure they'll get a matter of time. I mean, give or take, you know. Dr. Drill, how you doing? This makes my brain hurt. I love it. Makes mine hurt too, honestly. If I'm being frank. So spaces obviously don't work. So what did I say there were? 5 wide? So F should be in this tile here. Why isn't it? Why isn't it in this tile? Yeah, it should be in this tile here. And it ain't. Because, let's see. Space width. Where is it? Space width of 5. E technically ends on this column here. So space starts here. 1, 2, 3, 4, 5. Ends there. Ends there. It just ends there. So the next character should be starting here. What does F actually look like? This guy. Goodness gracious. So yeah, so then it should have 1, 2, 3, 4. 1, 2, 3, 4. That's what that should be. And then on the next tile, yeah. Let's see, this one? Yes, 1, 2, then down 1, and then over here like that. That's what it should look like, minus the this stuff. So that's what it should like. Should look like. That's not what it looks like. So that's cool, I guess. Why did it? Did it just like skip over the character? Is that what happened? Did I accidentally increment it twice? I have no idea because everything's red. So we're gonna change the fade speed back to 1 frame. Large gap for the G as well, probably. Oh no, it's fine. I did change my font back to the older version that was only like a pixel wide. So the font does look like trash. Because, I mean, that's why I changed it. But it is thinner. which is why I wanted to test it out. All right, reset. That wasn't the reset button that I wanted. Reset. Thank you. Boop. Yeah, still doesn't. It's skipping something, or it's adding a new one. I don't know. So let's actually break somewhere else. Let's break. At the enter space. Yeah, let's break there. Okay. Where's our values? Watch window. Width 5. Offs. Oh, it doesn't matter, right? That width doesn't matter. Rather, the shifts don't matter. Buffer index 18. It's 2. Okay. So 0, 1, 2. That doesn't seem entirely right. Does it? I'm in the middle of something. How? Huh? That is hexadecimal 18. Number 1. Which is 24. So that's the 4th. 24. That ain't correct. That should be the one before, shouldn't it? That's the 4th one. That's the 3rd one. Never mind. I can't math. Alright. Cool. Alright, so what does this thing do? What does it do? Can I actually... That's wrong. That's very wrong. Okay. Load up 5, store that in the width. Fine, whatever. Clear carry, add the current offset of 2. That's correct. Set the carry, subtract 8. It's an underflow. Compare that. Carry is set. What? Let's just do branch plus then, I guess. Because yeah, that would screw things up, I think, a little bit. All right, let's try this again. All right, underflow. There we go. Load 5, clear carry, add carry the offset 7. I didn't need to do that. I could have just stored that. I could have just... Oh, no, I couldn't have, because it would have been minus. Never mind. Never mind. Arc Sam, how you doing? Welcome. But okay, so let's. What does this look like? Underflow shouldn't be changing. Shouldn't be adding 1 to the index. Okay. Underflow should not be doing this. Underflow should instead just be incrementing that, and then jumping to load jar. What do you mean? Oh, capital. Let's try this again. What? It ignored it. Add carry and then store that in the offset. Please and thank you. Helps when I, like, save my work, right? There we go, that's better. Okay, now we have spaces! Hooray! Guess let's put a space after the H as well. And see how that breaks. It didn't! Holy crap! Overflow case? That's this one right here, the H. So the space ends. It ends right here. That's the last column with the space. No, that's a lie. The last column of the space is this one right here. So 1, 2, 3, 4, 5. And this right here, that column is part of the H. Let's look at someone's face when they find a bug and then the solution to it. That happens sometimes on this stream. For me, I think it's more of the confused why. Why did that happen kind of face. But I very much welcome, like, finding bugs. I very much welcome that. Alright. But yeah, so that still works, which is cool. Yeah. Alright. Okay. And, so I was thinking of doing some, like, other bizarro world optimization stuff, where, there are no bugs, only features, right? Where I write the writing the buffer code, in RAM. So this buffer code, right? So what all this nastiness does, is it reads RAM. So from here to here, it reads that. Why is all this red? That shouldn't be red. Edit breakpoint on the right. Okay, edit on read. Why is this still red? Thank you for that file, appreciate that. Read, write, or execute. These guys should not be red. Because red is like reads. Isn't it? Nope, red is writes. Why is that being rewritten? What? Oh, is my, like, clear routine bugging out? Only insects. Yeah, something like that. Compare X to A0. Okay. Clear the buffer. Where is we? Well, actually, let's have a look at the fade speed first. Do not fade. Okay. There we go. Nope. Fade speed. Custom, please and thank you on 1 frame. That's better. Okay. And it looks like it's not even writing the last, what's it? The last, tile there. So if I turn on this guy again, bam, we hit it. If I vote this guy, 258. Let's write that last tile, shall we? Shall we? So we got 20. Where is it? Where is it? Where is it? 21. No, let's. Oh, it writes 21, right? But it doesn't. It doesn't clear or send 21 to the CPU. Let's see if all 21 tiles, okay, fit in NMI. I don't think they will, but let's see. That's somewhere else. Okay, that one doesn't exist anymore. Put that down there. It does. Let's go to the next one. So it actually updates the. I didn't write the thing. The thing. I didn't mark it. Okay, marked it. 259. It still fits in NMI. Barely. It barely fits in NMI. Okay. Okay. Now I have like a little bit of motivation though to write a thinner font. Because if I can write a thinner font and fit a name, the longest possible name, in 16 tiles, that'd be fantastic. Because then I could have like 16 names per name table. That'd be kind of cool. Or if I did like a variable number of names per name table. Oh. This is only getting more complicated. Mind your legibility constraints for NTSC. Right. Yeah, I know. Which is one of the reasons why I moved away from this font into the other one. So if I go back to old, and then make this one like that, and then over here make clean, and then make. Reload that. Disable those. Bam. Which is why I made this font, because this one is reads better on NTSC, because it's thicker. Making them legible on a CRT is difficult. Yes. I would like a working CRT to be able to test this more directly. Yeah, because I know there's like filters out there for this. So like if I go ahead and enable the filter there and close out of this. Whew. Filter takes some processing, and it me having everything else open like slows it down. There it goes. Options, video size 4x. So this is still readable. The other font isn't at all. The Major Potato, how you doing? Welcome, welcome. So this, you can actually read the names, right? You can read the names, but if I go back over here, and use that old garbage font again. Make it. Come back over here, reload it. That's a lot less readable now. Right? You can still kind of read it, but letters are starting to like smudge together, and there's some color artifacts in there as well, right? So the letters don't really come across as good. Simulated, yeah, it is simulated, yes, but it proves my point. VHS flap. I actually have a VCR sitting right off screen that both of my my NES and Famicom are sitting on right now. And I have cassette tapes over here. Cassette tapes too. Where's my... So this is a digitizing project I'm working on. Tape number 2, that's what that says there. This is actually a wedding tape from one of my aunts and uncles that are no longer together, which is funny. So, I don't think they want that anymore. My VCR is propping up my PS3. I have a PS3 somewhere, but it don't work. Oh shoot! Holy crap! Tim Badoo! Badoo? I don't know how to pronounce your last name. I apologize. How are you doing, good sir? Hello and turtles. Hello! Tim Bodette. Got it. Stylish Jupiter, how you doing? Jaboko. Badoo sounds like a Pokemon. We're here to collect Jim's Bodette. Tim's Bodette. Tricky Lady, how you doing? Racing to save the day. How you guys doing? I was working on some lettering and kerning and stuff, and I actually got it working a little while ago. So I was just talking, actually. But hey, how you doing? Yes, 8-bit. So, this project for tonight was getting variable width fonts working on the NES. And in fact, you know what? Hang on. Hold up. Let me turn it off real quick, and I'll actually run this on real hardware. This isn't my main project, mind you. My main project is a runner game. So if you've ever like not had internet and tried to open up Chrome and you got that T-Rex runner game, that's I remade that on the NES. Let me kill the what's it? The filter, no filter, and then open up that. So this is my main project that I've been working on since like October or so. Yeah, so it's a infinite runner. The longer you stay alive and jump over things, the higher your score. And this level is entirely procedurally generated, based on that level CDC at the bottom there. But yeah, so I wrote this entirely in 6502 assembly for the NES, and yes, it does run on real hardware, and I can show you in just a minute here. This one though, I want to grab that and put that over there, and then go up here. But how was your stream, Tim? What were you working on? Doing anything interesting today? When are you putting Turtle Princess 6502 assembly? Yeah, Tim, when are you? Come on. I don't know what it's called, but in Europe it was common to use an antenna output on the NES. Oh, so the RF output. Then pair that with a terrible TV and you have a fun time. Yeah, that would be RF output, and RF output on anything is trash. Alright, so let's see if it does. It does, okay. So I'm going to go ahead and swap that real quick. Turn off studio mode. So this is my real hardware here. This is the NES off-screen that I've got a Never Drive in. So this right here is my game running on real hardware. Doing some preparations and learning reinforcement, trying to practice. I tend to learn proper home row fingers. Oh, okay, nice. Are you relearning like QWERTY, or are you throwing in a different keyboard layout there? But yes, this is my game on the NES. Time, however, for bed. My next stream is less than 8 hours. QWERTY. Okay, so you're going from QWERTY to QWERTY. So I had a similar... I did something similar, rather. Relearning typing. But I went the shotgun route, and I don't use QWERTY anymore. I use Dvorak instead. That purple font color makes it so blurry. It kind of does. I'm not. I don't even remember setting the font color honestly, so that might change. But yeah, I figured relearning something that I already knew was going to be really hard. So why not just throw something different at it? So I did. I threw a different keyboard layout on my hands so I could relearn how to type. I can do about 65 words per minute with crazy fingers, but I hope we're learning to improve things. Crazy fingers? Was that like a hunt and peck kind of thing? Mr. Squarepeg, how you doing? Thank you for that follow. Appreciate that. But yeah, I had a lot of really terrible muscle memory things and bad habits on QWERTY. It is really hard and painful. I have to constantly think about what finger is used. So yeah, so I had things of like where I'd lift up my entire hand to hit like the period button or whatever, right? The period key, and I knew it was wrong. I knew it was wrong, and I shouldn't be doing it. So I figured, how can I fix this? I want to relearn how to type, but I can't really reuse QWERTY very easily, right? Because unlearning bad habits is hard. So I did the next best thing, and then I tried to learn Dvorak, and for a little while I had both keyboards installed on my computer, and I wasn't making any progress. Right, so I uninstalled QWERTY, so I only had Dvorak on my machine. I couldn't type for about 2 weeks-ish, but after that, I fixed my typing, essentially. So I'm as fast as, if not faster than I was before. My left index finger hits Y and D. That's far. No. What are you doing that for? What are you doing that for? That's just all kinds of wrong. That finger shouldn't be touching either one of those keys. Well, right index hit B. I mean, that's either or, because the B is the same distance between the two. I have a Columnar keyboard with thumb clusters. Ergodox. Oh, those look nice. I advise something more like a sane plank though, because this gave me serious headache switching over. I can see that. Yeah, we use AZERTY in Belgium. It's very annoying to guess which button is what in games. That's one thing I actually realized after I switched over to Dvorak, is a lot of games don't do inputs correctly at all. Some do, and those games are godsends, but a lot don't. Doesn't really count as relearning, I guess, but I started using a US layout for programming because all the things regularly are in logical locations. I guess you're originally using some sort of AZERTY or European layout, UK layout. I'm only using my index finger on my right hand, and I still do 100. How? Switching to Dvorak, I didn't get faster, but it helps my wrist not hurt like hell. Yeah, that too. I mean, like, I might not be faster in Dvorak, but that wasn't really the goal. So, I mean, it's still a win. It's a bad space and stuff, of course. It really is. My typing speed is about 20 to 30 words per minute, while concentrating on it, and slower when I stop to retype words. I actually notice bad finger usage. Oh. The chosen one, yeah, right. Games that what's the scan codes? Yeah, what are scan codes? What are those? And it doesn't help that like SDL and Windows read the keyboard differently, which means that like my keybinds in my emulator, depending on gameplay and like emulator things like resets and like opening up the debugger and whatever, can overlap even though they're different keys. Because QWERTY versus Dvorak, because of course. I've had that issue before, actually. So, yeah. Nordic keyboard layout is weird for programming. I mean, this one's arguably weird for programming, too. because you'll notice that I'm using Programmer's Dvorak, which all the numbers are on the shift layer. Oh, shoot, I didn't mean to do that. Okay. I forgot that shift is my select key, which starts playing my broken sound engine. Well, and now it's big. Beautiful. So I have to hit shift to get the numbers, and they're all out of order. They're different. And the regular layer has brackets and things and all that rearranged. Not actually before these symbols are awkward locations. These are too, kind of. Well, they're less awkward, I think. They're more laid out for programming. Every special character involves alt greater or shift. Oh, it'll be hard for me to wrap my head around getting. Oh yeah, no, thank you. With the, I don't even know what those are. The circles and the dots. I know in German the dots are umlauts, right? Compose key. The compose key. Yeah. So I don't have to worry about like any of that stuff really, except like when I need to. I don't ever actually need to type those. In fact, the only like other language that I ever do type is Japanese, and I have a keyboard installed for that one. So I wonder if it'll actually will it actually show up as? No, it won't, because it's still Dvorak. I forgot about that. Luxury of only knowing one language, right? But I can still type in, you know, other languages. But that's a Windows thing. That's that was a pain to get to work, by the way, because like when you first install like the other keyboard, the layout, because it's phonetic, right? So I type out how it sounds. But like for Dvorak, everything's in a different spot. So when you install the other keyboard, it maps the sounds to QWERTY instead of Dvorak, so I had to change that too. That was a little interesting figuring out. Finally free from your sister. Congrats. I installed an alternate Dvorak for Windows that has an alt greater key with all kinds of special symbols in a layer. Nice! And it shows in OS. Nice! Not bad. So that must have been one of the the keyboards, the layouts built for Windows, and I mean that specifically because there's a program to modify keyboard layouts for Windows that I actually used for mine, because this is actually a modified Dvorak Programmer's Dvorak layout. Like I think the @ and the star were down here or something stupid, and yeah, these oh, you can't see this. These keys over here were different than regular Dvorak, and I was used to regular Dvorak with those keys there. I think the shift keys here, the question mark and the plus, I think were up here. And I like those better over there instead of up there, so I changed that myself. Yeah, user generated layout. Yeah. Con, how you doing? I don't think I said hi to you. Welcome. That's my keyboard god. Goodness gracious, mouse. Thank you for those files. I appreciate that. But yeah, so like I mentioned before, this is the game I've been working on for a while. There it goes. It's written out entirely in 6502 assembly. It uses seeds, so you can, you know, use your own seed or get a new one. It keeps track of your high scores, and I've also got a credit screen. So this is everybody that has subbed to me during this major project, this project on Twitch. So the white names are tier 1s, the purple flashy names are tier 2s, and those rainbow names are tier 3s. And I don't clear this list until the next major project. Writing an AI to come up with a better keyboard layout. Is it worth it? Worth it? I don't know, but does that stop? Does that ever stop anybody? Oh. People kind of did statistical analysis for it, for that, but it's hard to get the cost function right. Yeah. I mean, you could. I mean, you can teach a skeleton to walk with AI, and yeah, that kind of stuff. Why not keyboards? Like, the vertical stuff is kind of emphasizes cost of horizontal movement, while it's vertical movement that slows strains more. Deep learning for Alto keyboard layout. That looks like a workflow for the past year. I don't know if I'm comfortable with that one. That's a bit much, I think. That's a bit much, I think. Anyway, so it's getting close to 10:30. So I think I finished what I wanted to do tonight, which I'm kind of surprised on. And I thought I'd be spending more time with the optimization of writing things to the PPU, which I apparently didn't need to do. Yeah, so oops, I did a little bit of work on this off stream, so that's probably why. But yeah, so let's go say hi to somebody, shall we? Yeah, so I'll be back on Tuesday, same time as today. I don't know what I'll be working on. I'm gonna try to do some more homework for the sound engine for my main game here. I have a few ideas of what I'm gonna do. I don't know specifics yet. We'll find out, I guess. Next, I want to check out Assembly. Have a nice. Well, thank you for stopping by. I appreciate it. Assembly, I really enjoy it. I have a lot of fun with it, especially when it like breaks in weird ways. Because there's times where just like it just barfs on the screen. I'm like, oh goodness, that broke. That wasn't what was supposed to happen. What? And I find that unbelievably funny. And I really enjoy it. But yeah, so don't go anywhere yet. We're gonna see if there's somebody to go say hi to. Let's see. Anybody making something interesting? What is this guy doing? And we're also gonna check out the science and tech stuff. Oh, I just raided this guy the other day, though, didn't I? Did I? I don't know. I don't think so. But let's see who's in this OBS Dev War. What? That's interesting. What's this? But yeah. So if you guys want to stop by Discord, I got one of those to say hi. Oh, and Saturdays we do have a movie night if you're interested in that. I host that with another streamer. That's Saturday nights Eastern time. Details will be in Discord for that if you're interested. How long is this bike? All right, two and a half, almost 3 hours. All right, so let's have a look at this guy. I don't think I've rated him before. I make sure he's still. Yeah, okay, he's still going. All right. But yeah, come say hi with me to this guy. I don't think I've seen his stream before. There we go. So hopefully this will go good. But yeah, so I will see you guys next time. Thank you so much for stopping by. Thank you for the raids and the subs. I do appreciate it. You guys have a good night. I will see you next time, I guess. Yeah.